Testing. 1, 2, 1, 2. Good morning, everyone, and welcome to day 4 at the Cisco U Theater. In case you're not sure where you are, there it is. Thanks for joining me. My name is Patrick Gargano. I'm an instructor and a lead content advocate with learning and certifications. Those of you might be familiar already with some of my other sessions here over the last couple of years. I do a lot of work around CCNP enterprise troubleshooting. So I did a couple of labs this week and a breakout session on Tuesday. Those of you that know my sessions, you know I'm French Canadian. And all French Canadians, when they travel, always bring with them some sort of a maple syrup product to give away. And so I did that. I brought a kilo of maple syrup candy. And this is my last session of the week. And so I need to get rid of all of it before I head back home. And so I'm going to be asking questions during my session. And if you get the answer right, you get a candy. I mean, this is like literally Canadian gold, right? So it's very precious. So we'll just break the ice a little bit this morning. I know it's a bit early, so let's wake up slowly. Which city are we in today? Amsterdam. My questions on SD-WAN might be a little harder, but that's okay. Which country am I from? Canada. Fantastic. What's my name? And what's your name? There we go. And I can confirm that it's in fact Tim. And this is probably the most important one. What are we here for this morning? To hear about SD-WAN. So there's been a lot of talk. Oh, do you know that U2 song that starts on the live album? There's been a lot of talk about this song. There's been a lot of talk about SD-WAN, right, over the last 5, even maybe up to 10 years. So I want to kind of focus our attention on where we were before SD-WAN and then kind of bring you to what SD-WAN looks like now. Speaking of giveaways, though, really happy to have a couple of my colleagues here this week who just released the updated 2nd edition version of the Cisco Pressbook. So Anastasia and Dustin are here. They're going to be on their way this morning to sign this book. And I'd like to give that book to one of you this morning. But I'd like to very specifically give it to someone who's planning on perhaps taking the EN-SDWI certification exam, which, if you don't know what I'm talking about, is the CCNP Enterprise SD-WAN Specialist. So what I'd like to do is, when we're done at the end of the half hour, those of you that are thinking in the next 6 to 12 months to maybe take that exam, let's vacate the space so that the next speaker can come in and get ready. We'll maybe just huddle up here in the middle, and we'll do a little draw just with the maybe 10, 15, 20 people who are really, I would like it to go to someone who's just not going to put it on their shelf. Do you understand what I'm getting at? This is a brand new book, just came out about a month ago. The authors are here. They would love to give it to someone who will actually use it. So stick around at the end. We'll maybe go over here in the lounge area. I've got some little raffle tickets, and we'll give that away. And I do want to finish also by obviously plugging Cisco U, right? u.cisco.com. That's our platform where all our learning content is located. That's where you'll find all the SD-WAN content that I've been personally responsible for building. So the certification content, EN-SDWI Learning Path, or the course. I've also created a couple of other SD-WAN courses as well, like a fundamentals and a more advanced security and cloud SD-WAN course, as well as a cloud connectivity. Lots of SD-WAN content there. And I will also invite you to go visit Dalton over there at the CML station, because one of the things I want to mention to you is that in the latest versions of CML, there's a really amazing, easy tool to use to allow you to spin up quickly and easily an SD-WAN fabric in CML and get labbing and get going, right? There's also obviously dCloud that hosts a bunch of SD-WAN labs too that you can use. Making sense so far? We're good? Okay. I'm just going to put some in my pocket so that I don't have to come back to the bag all the time. All right. Okay, let's go back in time. We were designing our networks in a really specific way 10, 15, 20 years ago, and that it looked a lot like this. We had our data center, and our data center had all of our workloads, our servers. It had all of our security, our firewall, our intrusion protection, our DNS filtering, our URL filtering. Everything was being done there. And that meant that everything was going through that data center to get out to the internet, for example. And so we were deploying branches. Most of the time, those branches were connecting maybe over an MPLS link. That was just like the way that things were being done at the time. And obviously, during COVID and even before COVID, we had a lot of this, right? People that were traveling, working from home, working from hotels, having to connect back, and obviously using the VPN. But at the end of the day, we were seeing this kind of traffic flow. Everyone kind of understand what I'm getting at, right? Obviously, I'm not saying everyone was doing that, but that was a model that was being used quite a lot. And what SD-WAN is trying to, I guess, offer you as another way of thinking of your network design is to kind of open up that model, to avoid that and go towards something that's a little bit more exciting that looks like this. And what I mean by that is we don't maybe have to just use that MPLS link that's expensive. It takes forever maybe for your service provider to deploy it in far away remote locations. Maybe that remote location doesn't even have any kind of LAN connectivity. You'd have to use LTE or some sort of wireless connection. So what SD-WAN is trying to offer you as just a different way of thinking of your network deployment is that avoiding this and allowing this to happen. So obviously we still have our data centers, our HQ, which is connecting out to the internet as well, but our branch office is maybe connecting straight out. Our roaming devices are also going straight out to the internet. And most of the time these days, and I know there's been a pushback towards bringing our workloads back to our own data centers, right? There was this big craze, right? We went from on-prem to cloud, and people are like, man, that's expensive. Well, I think we'll bring a little bit of that stuff back to, okay. But at the end of the day, your data center, when you brought it back from AWS, it's still maybe a cloud-based data center, but it's under your control maybe. So this is what we're trying to leverage. We're just trying to simplify and secure that access for those workloads. So maybe it's SaaS, maybe it's AWS, Microsoft Azure, GCP. Like I said, it could be your own data center as well. So just trying to change the model a little bit, and that I think this is what SD-WAN is really well positioned to do, to kind of allow you to change this approach and go to something like this. Obviously, it has to be done securely, and that's what's really interesting with SD-WAN. I'll talk a little bit about security. Hopefully, I'll get to it at the end. But the idea is you can secure at the location, but obviously you can leverage some cloud security as well. So just to kind of set the scene, that's what we're talking about in terms of the way that we can deploy the SD-WAN solution. When I think of SD-WAN, these are like the key things that come to my mind. I want to have the possibility of leveraging SD-WAN wherever my office is. Is it a data center? Is it a branch location? Is it a remote user somewhere, right? So it doesn't matter where that's happening. And I think this is the big one here, right? A lot of people were selling or marketing SD-WAN initially as like the replacement for MPLS. You might have heard that language at some point. It's not a replacement for MPLS. We're still going to use MPLS as a transport if we want to. We're just opening it up a little bit more. We're going to use those inexpensive, maybe easily accessible internet connections that we can get at different locations. We might be able to leverage some wireless connectivity as well if we need to, right? So I'm thinking, I'm in Canada. Canada's a big country. I want to open up a branch location in northern Canada. Maybe initially I don't have an MPLS or even a cabled internet service provider going up there. So I might have to leverage something like this. I'm using all kinds of services in my current network. Those services need to be supported in my SD-WAN. So am I using voice? Am I using any kind of multi-domain stuff? Some SD access. I want to be able to integrate SD access with SD-WAN. So I definitely need my security as well. So all of these different services that I'm already leveraging, I want SD-WAN to offer that to me as well. And then finally, at the top, listen, it's the deployment model. There's a bunch of different ways we can do it. Typically today, the most popular one is we're deploying all of the controllers in the cloud and then opening up and connecting our branch locations to the fabric. But I mean, if you're labbing in CML, right, it'll be like a small on-prem SD-WAN fabric for you to practice with. That works fine as well. So there's lots of different ways that you can deploy that. Obviously, SD-WAN is now kind of including a lot of analytics and metrics that it can kind of provide information about the health of your SD-WAN fabric. So you can kind of monitor it, and there's some really cool things it does also with Thousand Eyes, right? I just want a Thousand Eyes plug here, but you can definitely do some really interesting analytics and just kind of analyzing how the performance is with Thousand Eyes as well. Just gonna kind of build this out with you. It's just kind of, again, some of the highlights and cool features of SD-WAN and why I feel like it's important that we talk about it today. So when we talk about SD-WAN, all the controllers and all of the control elements, these are all virtual devices that are mostly running in the cloud. But when we talk about the actual routers, the SD-WAN routers themselves, it's a physical router, right? You've sent it out to a branch location, you've powered it up, and it's booting up, and it's connecting to your fabric. But what's also really interesting is we can do it virtually as well. So you can use a Catalyst 8000V router, spin it up in AWS, spin it up on some sort of a VM, and add that to your SD-WAN fabric as well. And so that's what we do in CML, for example. When we build the SD-WAN fabric, it's all a virtual environment with our virtual routers spun up in there as well. As I said earlier, we can deploy this in the cloud, on-premise. When Cisco helps you deploy it in the cloud, it's going to have a lot of redundancy. You're going to have a couple of control plane elements, extra ones that are going to be built into your fabric as well for redundancy. I think this is like one of the big highlights for me in particular. Again, coming back to my example, right? I want to open that branch location in northern Canada. It's very remote. I just want to ship out the router over there and have someone plug it into that internet connection and just kind of stand back, let it boot up, and then let it do its thing. There's a bit of magic, some plug and play, some zero-touch provisioning that happens. It's going to reach out to your smart account, your virtual account, to figure out who it belongs to. It's going to join and connect to what we call the validator. Does anyone, here's the first couple of questions here. So I just used a funny word, the SD-WAN validator. Does anyone know what it was called before the name change? Now it's validator. It used to be called VBON. There we go, sir. So I'll get to that in a second. This was just like a preview of more candy to come. But the idea with that is that the device is granted access to the fabric. And once it joins the fabric, it'll then pull its configuration and then start doing the routing job that it needs to do at that branch location. I think don't forget that when we talk about SD-WAN, what are the first two letters? Hang on a second, get a candy ready. SD-WAN. Software defined, there we go. Software defined. So what does that mean? It means this. We're taking the traditional approach of our router that had everything built in. It had the data plane, the control plane, and the management plane. That was our router that we've been doing this for 20, 30, 40 years, right? I think we have an old router over there from the 80s. You know what I'm talking about. That was the way that it was done. What we're suggesting with SD access, SD-WAN, anything at SDN, we're taking the router and we're blowing it open. We're pulling the control plane out. So another device will be the brains, right, and control how routing happens. The router will still have its data plane, right? It has to actually forward packets and traffic. And then we'll pull the management out. I don't want to, if I have 1,000 branch locations, I don't want to have to remotely connect to all of them to push an OSPF configuration change. I want to centralize that as much as I can, and that's the magic of SD and SD-WAN, right? Where I'm going to pull the management out of there and centralize it somewhere as well. I want to be able to do this very quickly as well. So what's interesting with SD-WAN, if you kind of spin up a fabric, and you can do that, like I said, in CML, and you stand back and let it do its thing, it's going to build a full mesh topology between all of the little branch routers that you deploy. And maybe that's fine in a small deployment, but that's probably not good in a 1,000 router deployment. So you can quickly change that. You can change the way the topology is to maybe a hub and spoke, or partial mesh, or whatever you need. So, and you can do that very, really quickly with by pushing a policy, and again, not logging into 1,000 routers, just logging into the management device, creating that policy, and then pushing it to your routers. I already mentioned this one, so I don't need to repeat it. We know that SD-WAN is giving you that flexibility for using different kinds of transports, depending on your needs, again. Okay, this is nothing new, but we're using the language a little bit differently. VRF, got candy ready. VRF stands for what? Pardon? And? There we go, candy. I'll give this guy. You get one too, because you helped. You guys all know about a VRF. Okay, so we know what the acronym means. What a VRF is just what? You're taking a router and you're creating multiple virtual little routers, routing tables inside, right? Isolating those, right? So you're isolating context. We've been doing VRFs for, yeah, exactly. I've got some gray hair. I see some folks too. We've been doing it forever. We're going to still do the same thing with SD-WAN. We're just going to call it a VPN. I know what we're doing is we're using VPN in a different way. You guys, when you think of a VPN, you're thinking IPsec VPN. You're thinking site-to-site VPN. I'm just using VPN to define the segmentation that I'm creating in my different locations. That makes sense. I'll come back to this concept in a little bit. Obviously, I want this. We're going to talk about this thing as well, the management device. It's now called SD-WAN Manager. What did it used to be called? we manage. You can get multiple candy, by the way, if you keep giving me the right answer, because I need to get rid of the whole bag, right? So this is really cool as well. So what SD-WAN offers me is the possibility to monitor the quality of my links, the performance of my network, and kind of adapt and say, okay, Office 365 usually takes this link. It's not going very well this morning. We're going to revert to this other link instead, right? We can react to that problem. And more recently, it's evolved to something called application quality of experience, which is extremely cool. What basically it does, what it says, it's monitoring the application's performance, making sure that the quality of the experience that the user is seeing is the best it can. So if it's using one link and that's not working well, I might want to use a different link. But what this gives you is a bunch of really neat features to kind of optimize and maximize the use of those links, those WAN links. All right, last one here. We've been talking about security a little bit. Obviously, I need this whole SD-WAN fabric to be secure. There's two kind of levels of security. We're going to use DTLS or TLS tunnels to secure all of the kind of management and control plane conversations that are happening. But then we're also still leveraging our good old friend IPsec to establish the tunnels between our branch locations. So there's multiple levels of security depending where you're looking in the fabric itself. And this is all happening with certificates, right? That's how the authentication is going to happen and allow my tunnels to come up. This is, I think, probably the big highlight for most of you. The idea that with SD-WAN, I can quickly and easily expand and connect out to a bunch of different types of SaaS services that are available in the cloud. I can obviously extend my SD-WAN fabric to the cloud. So one of the courses that I built that's available in Cisco U, we have you kind of log into an on-prem, right, an isolated lab environment, and then we have you spin up a couple of Catalyst 8KV routers in AWS and let SD-WAN extend the fabric up to that location and access a server that's there. And so we've got our branch locations connecting through the fabric to AWS to get to that server. So you get to practice that in some of our labs as well. And then obviously we need all that security. So again, what's really interesting with the security is there's two ways of looking at it. You can look at the kind of on-box security that you can deploy. So you've got a router at that branch location in northern Canada. You can turn on a bunch of security features there, obviously firewall, URL detection, that kind of stuff. But there's also loads and loads of security features that we can deploy through Umbrella in the cloud itself. And I've got a slide towards the end that kind of breaks that down for us. So far, so good? Okay. This is the big picture. I'm just going to zoom into a few of these different things over the next few minutes. So what I want you to get out of this big picture of the SD-WAN fabric, which this diagram is not of my creation. I don't know if Dustin and Anastasia are here yet. Are they hiding? There they are. So Dustin told me a couple of days ago that he actually created the first version of this diagram, and I stole it from him. And then I made it pretty and used new icons. What I want you to take away from the diagram here is just the way that we've split what I was saying earlier, right? We took the router and we blew it open, right? We took the management out, we took the control plane out. So this is what it's basically showing you. So maybe we'll start at the bottom here, the easy stuff. The data plane are just the routers at your different locations that are just connecting your users to your SD-WAN fabric and connecting to the network, right? So that's just and these physical routers, virtual routers, ISRs, Catalyst 8K, doesn't matter what they are. The one thing that I realized maybe isn't really clear, well, actually, yes, I did put a little call out over here, I'm glad. So these funny little lines, all these represent are the IPsec tunnels. And don't forget what I mentioned earlier. If you let SD-WAN do its thing, it's going to create a full mesh of SD-WAN tunnels between all locations, which is kind of scary and interesting at the same time, but you can tone that down a little bit. This is all of your transports, right? So the different transports that you've got connected. If we keep going up, we've got our control plane. So this is what the device is now called, the SD-WAN controller. It used to be called V what? Sorry? Let's help him out because I want to give him the candy. What's it called? vSmart? vSmart, that's what it used to be called. So this is the control plane device. This is the brains, okay? This is where all of your routing decisions are going to be happening. This is where if you decide to configure OSPF or redistribute or push a policy on how the routing is actually happening. I want these locations to be able to talk to the data center, but I don't want these locations to talk to, right? This is where I can make that happen at the control plane. The management plane is this guy over here, SD-WAN manager, right? It's where you log in. This is your single pane of glass. That's where you will access your fabric, and this is where you'll do most of your work. There is another little mention here of what we call the orchestration plane, and this is this guy over here, the validator. We used to be called the vBond. This is what I just like to call it the gatekeeper. Anytime you spin up a new router at a branch location, the first thing it's going to do is try to reach this guy. And this is the one who's going to see if it should join the fabric. This is the one who's going to let the router in or refuse it. So authentication happens here, and this device's responsibility. So this was just like a high overview of all of them. I'm just going to quickly go through all four with some highlights of them. So like I just finished saying, kind of repeating myself here, the validator, it's the gatekeeper. It's where things happen initially to authenticate the device, to authenticate the routers, excuse me. It's a virtual machine. Usually it's running up in the cloud in AWS or something like that, and Cisco will take care of managing that for you. And this is what, once a router or a device that wants to join the fabric authenticates, it's going to send the list of IP addresses that those devices need to know to be able to connect to them and establish those DTLS tunnels that I was talking about earlier. It's also going to help with NAT, because sometimes these little routers are hiding behind a firewall, maybe. And so if there's some NAT happening, this device will help detect that and share that information out to the other devices. And like I said, it used to be called vBond, now we call it the SD-WAN validator. The control plane is also a virtual machine. And usually if you deal with Cisco to help you spin up your SD-WAN fabric, they'll spin up a couple of these for redundancy, load balancing. And the idea with this is it literally is the brain of the network. This is where all of the routing decisions and control is happening. This is where you're going to create your different data plane policies and push them out. And what I like here is it literally does act like a route reflector. And what I mean by that is, here's an example. If I have a branch location and I turn on an interface and I configure an IP subnet and I plug a bunch of PCs here, so basically I've created what you guys might have called a VRF, I'm going to call a VPN. I want to advertise that to my other locations. I don't send that information here. I send that information here, and it's going to send it down to where it should go. And this is where it comes up to you, where, do you want to advertise that subnet everywhere or just in some specific locations as well? As I said, this is the one that you're going to be connecting to, right? Logging in, doing all your work. Again, it's a virtual machine that's being spun up in AWS. And this is where you get to do absolutely everything. Create templates and policies to simplify and accelerate your configuration, accelerate your management of your SD-WAN fabric as well, and allows you to just kind of standardize it, right? If you're deploying 100 routers and they're identical, obviously the subnets might be different at the locations, but a lot of the configuration will be identical across those 100 routers, then you can use these, what we call these templates, to be able to kind of simplify that process as much as possible. The routers, they're just routers. Like, yes, they could be virtual routers. They can be hardware routers as well. These are the ones that are going to use that zero-touch provisioning to be able to connect to the network as well. We're going to build those IPsec tunnels I was mentioning earlier between your different locations. And what I mean here by it supports all these different types of routing and VRRP is at this, let's say, branch location down here, do you have OSPF running? Do you have RIP? Do you have EIGRP, static? What's going on down here? I'm going to want to advertise whatever's happening here to other places. So I'm going to want to maybe send that information up to the controller, and the controller is going to send that back down to the other locations. So that's what we're getting at with the WAN edge device itself. Just a quick mention, obviously, there's been a big evolution in the SD-WAN product itself over the last, since the acquisition, which has been quite a few years now. Initially, we were using one type of code, but now we've migrated pretty much exclusively to iOS XE. So iOS XE routers, quite a lot of them support SD-WAN, and you can use them in this kind of environment. Okay, so hopefully you get a sense of how it operates. But I guess what we really need to understand just a tiny little bit is a bit more of the language around SD-WAN. And what I mean by that is what protocol is actually making this all happen? It's this one right here, the Overlay Management Protocol, OMP. I'll be honest, if you look at it closely, OMP looks a lot like BGP. What I mean by that is it's used to advertise a bunch of information. It's more than just a routing protocol, right? If you think of OSPF, what's OSPF doing? It's advertising prefixes. That's about it. BGP does more though, right? BGP advertises prefixes, but what accompanies the BGP prefixes? A bunch of what? For candy. BGP advertises local preference, MED, what do we call those? BGP? Thank you. Yeah. So OMP is like BGP in that not only does it advertise prefixes, it advertises a bunch of other information as well, which is really, really critical to how the SD-WAN network operates. And what I mean by that is, okay, it'll advertise traditional 10.1.1.0/24 prefixes. I'm going to call that an OMP route. What else does BGP advertise? It advertises like next hop information. But usually when BGP advertises next hop information, it literally is just that. It's like the IP of the next hop, right? The next hop IP is a good idea, but what happens if his IP changes and I don't know about it? I'm still trying to send him information on the wrong IP address. So what we'll do instead is come up with a concept called a TLOC, a transport locator, which is like a next hop, but way more powerful. It's going to combine three things. System ID, so he has a system ID, so I'll have that. The transport that I need to use to reach him, so am I using the internet, am I using MPLS? And the type of connection I have with him. And usually it's the tunnel, it'll be IPsec. So now my next hop to reach him isn't just an IP, it's a combination of a bunch of information that we call a TLOC route. And it doesn't even stop there. This is probably the coolest thing. Let's say in your data center you have a firewall and you decide that when branch locations talk to each other, traffic needs to hairpin through that firewall before it goes to the other branch. I can advertise the firewall as a service in SD-WAN so that my controllers tell the other routers, okay guys, when you guys are talking to each other, when the 10.1.1 talks to the 10.2.2, it has to go through this firewall and back down again. So that's very, very powerful stuff. So that's what we call OMP. It's the control plane protocol. It's running within these TLS and DTLS connections. Like I said, the whole point of it is to think of BGP, but think of BGP++, of all the extra stuff that it does as well. But it does do attributes as well, right? Like to decide what the best path is. It's doing all of that stuff as well. Okay, this is a fun little slide. Oh, jeez. I need like a whole other half hour. Okay, let me just go. Bear with me here. I want to skip this one. I really want to do this one. I think this is my favorite bit of the presentation, and I know Dustin quite likes this one as well. Let's just build very quickly what the fabric would look like with a couple of branch locations, okay, in an SD-WAN setup. Here we go. I've got two branch locations. I've got a branch location over here, WAN edge 1, system IP 10.255.255.11. We're going to call the site 10, right? That's one of the concepts of SD-WAN. Each site has a number to assign it to. It's connected to two transports, an internet transport and an MPLS. We've got another WAN edge device over here, another location, different system IP, different site. So far so good, and I've got a controller at the top. Nothing much is happening. Let's kick it off. First thing that's going to happen, we're going to build and we're going to authenticate and then build these DTLS tunnels from the WAN edge devices to the brains. Now what's going to happen in here? OMP is going to start running in those tunnels, right? And we're not sending that out clear text. We're running in the DTLS tunnels. And what's happening with these OMP updates and information exchanges is everything I was talking about. It's going to advertise the TLOC information, that next hop reachability that I was talking about. It's going to advertise security information and policy information as well. Now, once I get that information going, the next thing that's going to happen is because I've got this thing over here, no, maybe not. I've got TLOC information. TLOC information is giving me next hop information. So this OMP update that I received was telling me about the existence of that neighbor, and the same thing happened over here. He learned about the existence of this one. And they're going to build IPsec tunnels across these two transports based on that information. So now they know they exist, and they've authenticated each other. And we've got secure tunnels. What are we going to do with these secure tunnels? There's a couple of things. We're going to run BFD in those tunnels to make sure that those tunnels are healthy and everything is working okay. And obviously, the user traffic is going to flow through these tunnels as well. And then we're going to start connecting devices. We're going to turn on a subnet over here, which you guys would call a VRF. I'm going to call it a VPN. And notice how this subnet, let's say 10.1.1, is different from this subnet, 10.2.2. But because they're in the same VPN, guess what? They'll be able to talk to each other. And is it going to go like this? No, it's going to go either like that or like that, depending on which one I'm using. Am I load balancing, or am I just using one link? But then what happens if I create another subnet, but I don't want these ones talking to each other? I create a new VPN. But hang on, I want to do the same thing over here, so I'll use the same one here. So that means this one and this one can talk to each other, and this one can talk to each other. Do you think I can do some route leaking if I need to? Yeah, I think I can. Yeah, of course you can. You can do some route leaking as well. Listen, I know the half hour went by too fast. The whole slide deck will be available for you guys to download. Just to give you a heads up of what's in it, I do talk a little bit about SaaS. I could talk for a couple of hours on SaaS. There's like one slide on SaaS. But I mean, I just want to say this SaaS exists, supports really cool stuff, so have a look at that. I do talk a tiny little bit about how we can connect to the cloud, AWS, Microsoft Azure, GCP. So it supports all of that as well. And then I promised I had a couple of slides on security, so on-box security. This is all the stuff that it supports on the box, on the router itself. So it can do that. But then, like I said, you can also leverage Cisco Umbrella to get access to all of this extra security as well. So it's like the full Swiss Army knife of product here. It's really, and it keeps, I don't know if you guys have noticed, but I mean, when I started really exploring SD-WAN, the version of code we were using was like 18-something, 19-something. There's a version of code update that comes out every almost 3 months. And so the product is evolving constantly. They're adding new features to it as well. And I've really just kind of touched on the basics of it. If you're interested, as I said at the beginning of my session, if you're interested to know more about SD-WAN and you have access to Cisco U, you'll need like a full subscription to Cisco U. You can access, all I did here is I went to Cisco U and I typed SD-WAN in the search box. Just like sent me all of the different course content that we have. So I built this content, I built this one, I built this one, I built this one. These are all around SD-WAN. Loads of hands-on labs here. This one has 12, 11, 10 labs. I think the most recent one is this one. This one is running 20.12 code. I think this is 20.9. I think this is 20.11. So fairly recent. I do promise, though, that over the next few months, I'm going to be updating this one to 20.15. And so updating the course again. The technology is changing so quickly that I need to kind of keep up and updating the course content. And finally, my shameless plug for Dalton in the corner over there. So wave, Dalton. There he is. If you're interested to just find out a little bit more about how SD-WAN is supported in CML, have a chat with Dalton. This is really, really cool stuff. There's an SD-WAN deployment tool that simplifies this to build your fabric. Really, it's a basic fabric, I'll be honest. It's not like 50 branch locations. It's just a couple of branch locations, but it's enough, right? You get your controllers up and running, IPsec tunnels going. So this is all built into the latest versions of CML. Thank you for joining me this morning. I apologize if we ran out of time a little bit. As I said, I'd like to hand over the book to our authors over here so they can sign it for us while we're... And if you are planning on taking the certification exam, please join me on the side here. We'll have a draw with you guys so it can go to what would you say? Like, I want the book to go to a good home, I guess is what I'm trying to get at. Thanks for joining me this morning. Cheers. Can I please give out some more candy? Candy?
All right, this thing on? All right, we're going to go ahead and get started. Welcome, everybody. Thanks for joining. Hope you're having a good morning. My name is Cory Guynn. I'm an API architect on the Cisco Meraki cloud team. I've been with Meraki since the startup, say 14, 15 years now. Was one of the first support guys on Meraki, and then sales, and then I eventually kind of got tired of fixing things or selling things, so I wanted to build things. And now I am an architect where I've been leading really the API framework. So like everything from our open API structure to our developer enablement with documentation and to new technologies and integrations. So today, I'm really happy to talk about our recent developments with Splunk, where we have really revamped our integration with the platform, enabling you to really kind of leverage the power of both of these systems to kind of unlock some new use cases here. So the way I'm looking at it is that Splunk is turning the Meraki data into simple, relevant, and actionable information. Like, what does that mean? Well, we'll explain a little bit in a second here, but ultimately, there's a lot of data on the Meraki side of the house, right? And a lot of it is made pretty accessible. The whole idea of the Meraki dashboard is simplicity. But I've always said simplicity is relative, right? This is why we have APIs. Some people find it really nice to have a wizard, and another person's like, well, I don't want to have to do that wizard 1,000 times. Give me an API, I'll write a script, and it's done. And the same thing can be said about reporting and analytics. To me, I feel like it's really subjective. Like, what value or KPI is interesting to me maybe is not as interesting to somebody else. And this is kind of the problem we have when we try to make like a universal dashboard, is that it's not a one-size-fits-all every time. And so that's why I was interested personally in what Splunk can do for our Meraki platform. So again, Meraki has flexible interfaces. What does that mean? Well, it's not just a networking platform, but we also provide you, again, a web interface. We provide you a programmatic interface, whether that be a REST API, whether it be a push system like webhooks or WebSockets or MQTT. But ultimately, we're giving you the controls to tap into the power of the Cisco Meraki cloud, right? And with that information, we can unlock a lot of cool use cases. So if you're not familiar with what the Meraki platform ultimately encompasses, it's really the full stack. It's everything from your access layer with wireless and switches, it's your data center, it's your sensors, physical security with cameras. It's basically all that equipment, right? But then there's the cloud platform there that allows you to manage all of these devices, even if they're highly distributed. So really the real simplicity here is I can plug in a Meraki access point or a switch, it automatically phones home, downloads its config, and it starts working, right? And so that's all fantastic. And like I said, the APIs enable the efficiencies. So yeah, dashboards are great. But if you want to automate that thing you had to push a button every day, every week, you want to reset a password, okay, going into a dashboard again can kind of get a little annoying. And so you want to automate that. Sometimes there's just another service that is not specific to Meraki. Maybe another platform or service has added some value. And now we want to connect those things together. And that's where the integrations come into play. And ultimately what APIs enable us to do. And then finally, when you have all that information, you can now start anticipating new things. You'll have better insights to make better decisions as things happen. So when we talk about APIs, it's not just an API. Typically, an API is just it's an interface to a service. And Meraki has several services. But the main bread and butter service that we have is the dashboard, right? When you log into Meraki, you log into a dashboard. Well, that dashboard is powered by APIs, right? So we made the transition to go to API first a while ago, which basically means every new feature we build, we first build the API endpoint, then we build the pretty chart or the form or whatever. Because ultimately what would happen is people would say, oh, I really like this on this dashboard. How do I now do this on my dashboard? And so now we just do API first. And so that's the dashboard API. Webhooks, like I mentioned, it's basically an API, but it's just the reverse, where instead of you calling us, we'll call you when there is an issue, right? So if an access point goes offline, we'll make the phone call. We're not waiting on you to just call us every minute and say, hey, is it still online? Is it still online? Doesn't make a lot of sense. So that's webhooks. The other three are a little bit more niche, just at a high level. We can do location analytics, where our access points can actually listen for Bluetooth or Wi-Fi beacons and then trilaterate where they are on a map. Captive Portal enables us to allow people to connect to an access point, and then it prompts you with that splash page that says, okay, here's my brand, do you trust us, yada, yada, and then you hit okay. That's what that Captive Portal API is. And then MV-Sense is like that real-time sensor telemetry. So did a door open? Was there motion detected on our camera? What's the current temperature? What's the state of the door? That is delivered either via MQTT for real-time telemetry, or we also offer some webhooks and REST API equivalents. All right, so that's the Meraki side. Now, if we talk about Splunk, to me, it's just a powerful data platform. I'm sure there's some other benefits and things, but this is what I'm seeing with it right now, is an ability to take this data and make it, I don't know, more accessible, more useful to me. And to start with, it's like, okay, well, I can make some really fantastic looking dashboards. I mean, I do love good eye candy, and Splunk is really great for that. I've been able to take my really boring tables and turn them into really pretty pie charts on a map, and that's fantastic. But it really does help a lot, because I can't tell you how many times we've spent trying to build the perfect dashboard for people, and then at the end of the day, someone's like, yeah, I don't like that chart. I wish it looked like this, or I really don't love that color scheme. And like, we spent, years in research and all of this other stuff, and we're like, yeah, it's not for me, dog. So in that case, this is really great where you can start building your own presentation layer. So just to get a little bit into under the hood, what it means, what is Splunk? Well, basically, as I understand it personally, it's basically a really powerful search engine on your data, right? It's not technically a database. It's an indexer, which looks at all of your data and then puts a really clever search engine on top that you can then basically write queries, kind of like a query language, where you're putting in some additional filters and variables and all of that. But ultimately, you're able to filter and pinpoint the data that you need, save that kind of search result, and then flip it into a visualization. And that's kind of the concept. And there's naturally that layer where we need to ingest the data. And these are the collectors. Like I said, it's either a REST API, a WebSocket, OTel, however you can get the data in, then the system can then perform all of its intelligence on top of that. So again, there's a lot more to just the data side and just a search and a visualization. Naturally, there's a lot of capabilities of Splunk. I'm personally still learning a lot of them, but I have found there are just some really clever things in here that I didn't even realize I needed until I started using it. Just the ability of just, I don't know, pulling in information and then correlating it with other products and other data types that I'm just not used to doing when it was just a purely Meraki play. Now I'm able to pull in some like point of sale system or some third-party IoT product or just some of our other Cisco products. I can now pull them into a single area, use some of these additional tools to then actually tell a better story of what's happening. So to get started with Splunk, there's really kind of two flavors. There's the on-prem and there's a cloud version. Our integration will support both, but ultimately you get Splunk as a service, you set up an account, and then you start basically ingesting your data and doing something interesting with it. Again, there's all of these different types of interfaces, these APIs effectively, that allow us to ingest the data as well as to then get it out of Splunk in various forms. So at the heart of it, like when you actually log into Splunk, if you haven't logged in yet, I mean, you're basically going to come to a page that looks something like this, which is really just like the search bar, right? You have the ability to search the data that is in there. And at first, it's a little overwhelming, but honestly, with a little help from ChatGPT, I was able to write some really impressive search queries and understand the power of this thing. But ultimately, I was able to write a search line and it just pulls out all of this related data that it has been ingesting over time. And that's really nice because API data could have a lot of different shapes, right? And trying to structure it into a really rigid database is painful. And that's why there's special engineers just for database management. What's nice about this is you can just kind of throw it all in there generally, and it just searches and filters and kind of correlates and finds relationships. And it just makes it a lot easier to discover data, even if you're not exactly sure how you're filing the data. So once you've created a search, this is what like an actual search looks like. This is quite specific, but it's basically saying, look into my main index there, right? Like this is the main area where I want my data to be, the equivalent of a database almost. And then these pipes, these little lines here, kind of say, okay, take this data and then do some manipulation on it, maybe do some math on it, and then maybe relate it to some other thing, and then change the name. And then at the end of the day, you have a search that's been altered and shaped. And then that's your data output. So effectively, these are the different sections of each one of that search bar. And ultimately, it results into a filtered data to then even more specific data, and then I can sort it. So once we have the basics here, you may not want to be able to create every single dashboard yourself or every input yourself. And naturally, that's where a marketplace comes in. Splunk as well as Meraki both have really great marketplaces where we allow other solutions to interoperate with us to really extend the overall value. And so with Splunk, it's no different. Over 2,000 apps that are available in the Splunk-based market store. And so integrating with Meraki is going to be super easy because we are in that marketplace. And so what's the value, again, with Meraki plus Splunk, right? Meraki is providing the data. And that data is your full stack. Networking, internet security, physical security, that's what Meraki is providing. Splunk providing that observability, big data collection, big insights on top of that. And then you can take it further by adding workflows, actionable items on top of that. Who's it for? Well, if you're already a Meraki customer, that's fine, but you also realize that if you are managing a lot of Meraki accounts, maybe you're a service provider or just a large enterprise and you have a lot of Meraki environments, in that case, it's really great to use Splunk because you can aggregate all of those different isolated organizations into one interface and then start doing your analytics on top of that. If it's beyond just Cisco Meraki and you have other vendors, then in that case, well, this dashboard can then provide you that comprehensive look at it. And then finally, if you already have Splunk, you might as well add this on here if you also have Meraki because you're going to get the value of these insights. So at a high level of kind of the actual use cases, how you can think about it, again, whatever you can do with Meraki, which is a full network. But in this app specifically, we had to be really, we had to cherry pick what type of data we want to pull in from the Meraki platform into the Splunk. And that's because, well, data isn't free, right? It takes money to send it, to store it, and all of that. And so what we really focused on is getting our best computed data out of Meraki. So we pre-compute like the top access points or top switches or other trends. And then we pull that semi-computed data into Splunk. So then now it's efficient on that side of the house. And so as of last Friday, just a couple days ago, we have released a new version to the Meraki add-on for Splunk. Okay? It had been out there for some time. The original Splunk team built the Meraki add-on. But as you know now, Splunk is part of Cisco. And Splunk was like, hi, Meraki, you want to take your app back? And we did. And I have been leading that effort to revamp it to effectively to take advantage of all the developments we've made on our API. We were the subject matter experts, so we know what is best to put into Splunk. And we worked with them to actually revamp the entire application. But we weren't the only ones. So Meraki is definitely part of this. But we also had Catalyst Thinner and Thousand Eyes, Intersight, all of the various Cisco BUs. We are all working together to really get our different data silos together in a standard way into the Splunk system so that you can provide that analysis and create these multi-product style dashboards. So, all right, how does it work? It's really simple. You just go online, you download the Splunk add-on. So if you just sign in to your Splunk system, you can just say, I want the Meraki add-on. It installs it. And then at that point, all you need to do is add in your organization, your API key, some frequencies. And then you get to choose which of these inputs. So these are like the API calls we're making. So do I want to pull in my analysis for my VPN, for my APIs, for my access points? You can select that. Now, once you've selected it, it technically works by a schedule for our API. So just, if you wanted to do once every couple of minutes, once a day, it will make these calls. And if something in your environment changes, again, we'll send you that webhook that says, hey, something went offline or somebody started making changes to the firewall config. Here's your notification right now. Yeah. And so then once that data has arrived and configured into your system, like I showed you earlier, on the left side, you're just going to search and discover. And then on the right side, you take that data and turn it into a visualization. Okay? And it's actually not rocket science to do that. A lot of these searches, there's a little button that says visualizations. And when you click on it, it'll come up with like 3 different visualization options, like a line chart, a bar chart. I'm like, oh, that looks nice. And I select that. So again, you don't have to be a seasoned expert to make these types of dashboards. To kind of revisit a little bit more of the details of exactly what is in the new version of this app that was just released on Friday. You can see the previous one is V2, so we'll still contain all of that same information. Version 2 basically captured all of your network event logs, as well as any of your configuration changes and a few additional security flags, right? And that was the start of it. It had about 6 inputs. With this new version that just came out, we effectively increased that to about 30 inputs. And that way, we were able to cover all the key telemetry and configs from the full stack, right? So if you're interested in wireless or VPN or sensors, we have an input for that, right? So you should be fully covered, at least to get your baseline set of data. All right, so to kind of review that, again, the Splunk turns Meraki data into simple, relevant, and actionable information. And really what that means is I'm able to take all this random data, put it into Splunk, and then now turn it into something I can use, and it's more insightful to me or my team. You can get the Splunk add-on, like I mentioned, just from the Splunk-based store. You can really just search Meraki Splunk. It'll be the first listing. You can click on it to install, and it's free of charge for the app itself, right? So with that, I want to do just a quick little demo, just so we can kind of see what it looks like in real life. Okay, so. There we go. Let me just do that. All right, what we're looking at here is actually the Meraki dashboard. And again, I'm on the API team. So I'm actually concerned a lot more with API analytics than I am with VPN analytics. That's just me. And we were currently building this page right here, you see. Our users were having some challenges with API rate limits. As in, we give you 10 calls a second, and that's fine, but if you have a lot of people using the API at the same time, there can be a conflict, right? And it was challenging for our users to know, okay, who's doing it, when are they doing it, and is this, a security concern or just a traffic management concern? But we didn't give them that data to do anything with. At most, we might have given them like a request history log. And so I've been trying to champion us to build a dashboard for almost 2 years. I even went so far as building my own prototype in HTML and JavaScript so that the whole thing worked. And I was like, okay, engineering team, I pretty much built it. Just make it happen. And it still took like another 1.5 years plus another product manager to really get it to this point, which I'm really happy about. And it has been super powerful. But the thing is, this thing took almost 2 years to come into completion versus I installed the Splunk add-on, and I was just doing a test. And within that test, I was able to create this dashboard. And I did this over a cup of coffee. With a little bit of help from ChatGPT, I was able to create some really awesome search queries. And there's a lot of great templates that Splunk actually offers. I think it's this one. So this is on Splunk. You can see that they basically have like this component library where you can pull in all of these different visualizations, different like areas for your KPIs. And if I scroll all the way down, you can see that there's like complete dashboards, right? And so the idea is, you're like, oh, I like the way that thing looks. And you pull it in, but then you just update it so that it's pointing to your new data, right? So it's like, okay, that one looks really awesome, like this. Maybe I want my Meraki data to look like it's coming from outer space or wherever this is coming from, right? So like, that's how you can do it. This is real data. It's just I'm going to change it to my data. Yeah. So I'm going to go back to this page. So again, this is a really powerful dashboard that I created for API analytics. So imagine I'm like the network admin, and I have a lot of different integrations. I have third-party partners who need to install, a network at various remote locations, and then things start happening, right? And I'm like, what is going on? Well, one of the things we wanted to know is, again, how many rate limits are happening in a period of time. And I can now see this on a stacked bar chart. And like the red is 429s, which basically means I have hit the capacity of the number of API calls I can make in a period of time. And so everything's going to fail. But you can kind of see how that pattern starts to happen over time or certain days. And this is also informative because if I know I have a big monitoring or deployment job, I'm going to now be more, I would say, smart about when I run the job, right? Knowing is half the battle, and that's the insight, right? I was also able to do some other cool things like, we only had the IP addresses of the people making the API calls. But within Splunk, I was able to take those IPs and geolocate them, put them on a map, and then create a pie chart over which applications are using it from which region. So it's like, oh, that's pretty neat. And then there's a lot of other obvious things, pie charts and line graphs that you can make. One other thing I found that was super neat, again, kind of back to the rate limit issue. Sometimes I want to know exactly what that user was doing when the rate limit occurred. And in this particular visualization, I can hover over this. And so I'm hovering over 429, which is the code for rate limit, okay? But by me hovering over that, I can see which operations actually had the rate limit issue. I can see which application they were using, who did it, the admin, from which company they were working at, and then like the volume, right? So just with like a glance, I can see all these different behaviors over various, relationships of the same data set. And before, we just used to give our customers a request log, and that's all it was. It was just like thousands of requests. And now I have insight. Like that's the whole point here. And so for me, I started drinking the Kool-Aid because I was like, oh, this is exactly what I wanted. I wanted to build my own dashboard. I wanted to get my own information. And at the end of the day, if I want logs, it can also pull in logs. And that's all great too. Sometimes these things have their own value. But at the end of the day, I was able to now create this comprehensive dashboard. Now, there's a bunch of other things that we can do. I won't go through it all, especially because I can't see my screen. But if I were to show you the Cisco Meraki add-on, effectively, when you get the add-on and once it's installed, you can then easily add your organizations. Like I showed you in the slides, you basically add a new org, you add your API key and kind of your settings and all of that. And then at that point, you will configure your inputs. And like I mentioned, this is where you can now select the various data that you want to pull in and basically where you want to store it. And then as a bonus, we've actually provided, I wouldn't say like a full dashboard, but we've already provided pre-configured visualization components so that you could kind of drag them and then create your own dashboard, right? So you'll see each one of these sections like API data. if I were just to click on that one, instead of my full dashboard, you see just the one bar chart, right? But we've done that on purpose, and that way you can now copy or inspect each one of these components. And you can see this is actually the search that was made to make that bar chart, right? So that's what it looked like. But I don't expect you to have to write that, but you can copy it. And so that's the idea. Here's the search, here's the data, and when you click on this like visualization bit, it would create the stack bar chart, right? So ultimately, that's the idea. I will pop it back over to this section here. Yeah. So that's kind of like the whole concept. I really appreciate you guys taking the time to learn about the Meraki plus Splunk integration. I highly encourage you to test it out. Again, you can get a Splunk dev environment for free. Just sign up for a sandbox. You can install the Meraki add-on for free. You can get a Meraki dashboard account for free. So there's a lot of things you can do for free to test it all out. If you already have a system, again, it's just as easy to get started. If you have any questions or whatever, please reach out. There is a Webex room for this as well. I do appreciate any surveys, feedback, so make sure you smash that like button. It helps me come back to this every year, which I really enjoy, so appreciate that. And with that, if there are any last-minute questions before we close? Yep, we got a question.
You're sending the data, calling an API. Were you also thinking about streaming the data using OpenTelemetry?
Yeah, so the question is, we're only using a REST API. Are we interested in OpenTelemetry? Yes, we are interested in doing that. We're starting with the REST API because that's what we have on the shelf today, as well as webhooks. But we also realize that's a lot of data, and we want to make this more efficient. So we're looking at push mechanisms, and it might be OTel, WebSockets. It's going to be a solution, right? Yeah, perfect. Great question. All right, with that, I want to thank everybody. Enjoy the rest of your day. Thanks.
Okay, hello everyone. Hopefully you're having a good morning today here at Cisco Live. Maybe you're attending some interesting sessions throughout the week and learning about some new technologies that we have here at Cisco. So who's interested in becoming more efficient? Anyone? Hopefully that appeals to all of us, right? We're trying to be more efficient in our day-to-day work, in our life. We want to do things more efficiently and get the most out of our time. So today we're going to talk about maximizing your efficiency with iOS XE. So that means we're going to dive deep into programmability and automation, and specifically using our Yang models and Yang suite. So does anyone use Yang suite tooling today? Nice, I see a few of us do. Okay, we'll get into Yang suite and how it works and how we can actually leverage it to be more efficient. So hello everyone, my name is DeWeese, and I'm a technical marketing engineer here at Cisco Systems. So I focus all day, every day on iOS XE, programmability and automation. So my goal is to make your life a little bit easier. Let's get into the session today. So here's an overview of the topics. Basically, we're going to introduce programmability and automation, get into Yang suite and Yang models. Then we'll talk about device onboarding, device configuration, device monitoring, and we'll get into device optimization as well. And of course, I'm not going to leave you without resources and ways that you can move forward with being more efficient in your day-to-day lives. So first off, we have an intro to programmability just to get started here. So this is an overview of the iOS XE programmability and automation lifecycle. So again, we're talking about how to onboard your device effectively, how to configure and manage your devices at scale, as well as how to monitor your devices and optimizing them. So we'll break this down day by day as we go throughout the session today so you can see how you can be more efficient in each day throughout the programmability and automation lifecycle. So to start off, we have our stack for programmability and automation. So this includes netconf, restconf, GNMI, and gRPC. So before we get into any of those, who is using some of these programmable interfaces today? Anyone using netconf, restconf? Okay, I see quite a few of us are. That's awesome. So all of these programmatic interfaces are just another way for us to talk to or communicate with our iOS XE devices. So if you're using CLI today, this is just another way that you can work with, say, configuring your devices. Now, for each one of these programmatic interfaces, we actually have Yang models underneath, and that's how we're actually going to be talking to or interacting with our iOS XE devices. They all speak in essentially Yang model languages. So our Yang models, we have two main types. One is open config, so it's vendor agnostic, and the other is Cisco native. So our Cisco native models will, of course, help you get a little bit more granular with the configurations you can make for Cisco specific devices. Now for each of these, whether you're using OpenConfig or Cisco native, you can actually have two different types. The first one is configuration. Okay, I'm going to pause here. Does anyone want to guess what configuration Yang models do? They configure your devices, exactly. Okay, you got it, brownie points. Next up, we have our operation Yang models, and these are essentially our read-only models. So how do we get information or statistics from our device? Maybe what is their CPU utilization, or what's our current memory on the device? How much are we using? Now, for our Yang data models here, we're talking about many different types, but what actually is the data? What are we getting here? So we can think of our Yang models as actually a specific feature that we want to configure on our device. So maybe that's going to be AAA, for example. You want to go out and use your Yang models to configure a very specific feature on your device. We'll also get a little bit today into telemetry as well. So who is monitoring anything about your devices today? Anyone doing some monitoring? Okay, most of us are, right? So we can also use model-driven telemetry to get this data or get these statistics from our Catalyst devices. So in this case, we have two main types for telemetry, the dial-in and the dial-out. So dial-in is essentially a publication subscription method, and the dial-out is a push-based model. So again, we have netconf, restconf, GNMI, and gRPC. So typically, you'll see netconf or GNMI or gRPC for this telemetry use case here. Of course, you can use restconf, but you'll essentially need to do a lot of restconf gets, right? You'll probably have some type of loop or some type of cron job setting up a get request from restconf. But all of these are using the same Yang data models if we want to get telemetry. So again, this is the read-only or operational data models. The same thing we're using with configuration as well. So we're talking a lot about Yang models, but what are these, or where can you find them? Actually, all of our Yang models are free and publicly available over on GitHub. And this is different than some of our competitors, but you can go see the specific implementation that we have for our Yang data models over here directly. Now, this may look a little bit overwhelming. There's a lot of Yang models that you can look at, but we have them organized here by our iOS XE version release. So you can go into the specific folder to understand which models you're using on the specific devices that you have today. Now, within each folder, we're also organizing our Yang models into different categories. So in this top one here, we actually have all of our Cisco native Yang models. So this is modeling everything in the running configuration of your devices. You can see all of those modeled here in the Cisco native. And then if you see a Cisco and then a feature name and then -CFG, that means it's going to be the configuration Yang models. Whereas if you see oper at the end, that means it's going to be an operational read-only data model. So again, all of these are over here on GitHub for you to use. And today we'll specifically get into how to use Yang Suite to read, understand, and actually leverage all of these Yang models. So I know some of us are using Yang Suite today, but this is actually the tooling or the feature that we're going to be leveraging. And Yang Suite is a testing and validation environment. So you can actually use this to work with your APIs and send payloads to your devices. So this works with iOS XE, XR, and NX. You can actually load up your Yang models into Yang Suite, and then you'll be able to generate payloads. So that can be using netconf, restconf, GNMI, or gRPC. Any of these you can use to actually work with Yang Suite and say Yang Suite is hosted in an area in your network that has access to your devices, you can actually push those payloads. So maybe you want to configure something, you can use Yang Suite directly to configure your devices. And we'll get into details about how you can actually scale this up as well. We just recently released a new learning lab too. So this actually walks you through all of the different capabilities of Yang Suite. So you can see that from the QR code or the link here. And this is available at developer.cisco.com/iosxe. So you can find a lot of different tools there about how to get started with programmability and automation, including this learning lab. So now let's get into it. First of all, we want to onboard our device in a secure and reliable way. So how can we do this? We have a feature that's called zero-touch provisioning. Who's using ZTP today? Nice, quite a few of us are. So to leverage ZTP, we have the guest shell, which is essentially a Linux box embedded on our Cisco switch. So we can use a Python script and actually bring it on box, and then work with our APIs to actually configure our XE devices for the day zero operations that we need. So if we're going to be using a Python script for this and we want to work with the APIs, how can we actually generate this Python script? It will look something like this, where say we want to configure different features on our device, and we have many different examples of what these ZTP Python files can look like over on GitHub. But we can leverage Yang Suite directly by building up a payload. So here we want to configure something related to VLANs, right? We want to do this in our day zero config. Now we can actually generate a Python script directly from Yang Suite. So we're going to click on replays and then generate a Python script. And this will allow us to be able to leverage and reuse this same code over and over again. So you don't actually have to write Python code to be able to the script here. So that covers the day zero use case of device onboarding. And now we'll spend a little bit more time on configuration. So we're all configuring many devices, right? All day, every day. We want to make big configuration changes depending on what needs to happen within our network. And sometimes this needs to happen to many different devices all at the same time. So after we've onboarded our devices programmatically, now how do we configure them, again, reliably and at scale? So you may have guessed it, we're going to use Yang Suite for this, and we have a few different examples here. So the first one is actually using netconf, and in this case, we're going to do a GET request. So we want to understand what's happening currently on our device, how is it currently configured. So we can build up a GET request over here. So you can see at the top we have a get config that we have defined here for a specific device. And in this case, we're going to do something simple. We want to get the current host name. Now you can plug and play essentially any feature, right? This is all of Cisco native that's modeled here. So you can take any feature of interest, but in our case, we're going to build up the RPC, and this is what's generated. So we get the XML payload directly. Now we could take that or put it into a script, save it for later, or we can actually run the RPC directly within Yang Suite. So let's say we're going to go ahead and run it within Yang Suite. What we'll see here is exactly the XML payload that was just generated. We're going to push that to our device. And then we see here we have the host name that's actually returned. So this is telling us the current configuration on our device. And now we want to make a change, right? We're not happy with the host name. We want to change some config. So next up, we'll actually change this operation in netconf from a get config to edit config up here. And then we'll be able to actually input what we want to see our device have. So we're going to make, right, the configuration change. And we can run through the same flow here where we build up an RPC. And what we'll see is this is what's generated. So instead of having the get config, which we had before in the XML, now we'll have the edit config. And when we run this, we'll actually see the same payload, but instead of receiving information, we'll actually see an OK message. So what that's telling us is we were able to successfully push this config over to our device, and our device was able to configure successfully, so we get the OK message. Everything's good to go. We were successfully able to configure our device. So now let's take it one step further. Is anyone using Ansible playbooks for configuration today? I see quite a few of us are. Awesome. So you can actually use Yang Suite to generate your Ansible playbooks as well. So in this case, we just directly sent the payload to our device for both the get and the set. And similarly to what we showed in the day 0 example, we also have the option for generating Ansible playbooks as well. So once you build up a payload, you can actually go in and instead of hitting essentially like run the RPC or pushing it out to your device directly, you can go to replays and then generate your Ansible playbook. And you can define what exactly you want to have your file name, for example, the task name, playbook, all of that information you can customize here. And then you can see an example of what this Ansible playbook actually looks like that's generated, downloaded to your device. So again, this is just a quicker look here. So again, we have the generate Python or generate Ansible playbook. So both of these operations are really easily available to you using Yang Suite specifically. So now let's take a quick demo and look at how to actually use this. So here we are within Yang Suite. We're going to click on netconf. And from netconf here, we can actually build up our payload. So we click on our Yang set. And in this case, we want to change something about interfaces, right? So we'll load up all of our modules here. And we'll change this to an edit config because we want to make an update to a specific device. So now we can expand the interfaces here. And so for a specific interface, we can add, custom config. In this case, we'll add, say, a description, something super simple, right? And now we'll go ahead and build up the RPC. So you can see the XML is generated. We can push this directly to our device, or we can actually go ahead and generate an Ansible playbook right here. So in this case, we can sort of look at or investigate the Ansible playbook that was generated. And you'll see this exact XML that was generated by Yang Suite is included within this Ansible playbook as well. So now we can go ahead and work with it. So we have our Ansible environment set up over here. You can see we have our configuration. And then we can get into the host itself. So this is how we'll actually work with or talk to our specific device within the network. And now we can take a closer look at our config itself. So in this case, we've added a few more interfaces, right? We want to see that they've all been configured or something about them has been changed. So for these about 5 interfaces, we're going to go ahead and run this Ansible playbook generated by Yang Suite. So now we can go ahead and run Ansible playbook. We're going to be using this file generated over by Yang Suite. Of course, we're using our hosts that we were just looking at. And now we can see that this is actually being applied to our device. So we're running Ansible over here. We're running the specific play and task that we'd created over again in Yang Suite. So what we should see here is that everything turns out okay. We're able to successfully configure many different interfaces over on our device itself. All right, we got the OK message over here. And that means, again, we've received the OK message back from our device. It was successfully configured. So of course, we can go ahead and validate that too on our device as well to see that, yes, this config was actually applied. So let's quickly do that validation. We're going to access our device here. And again, this is the one that we were configuring from the Ansible host. And we see that all of these different interfaces are updated. So all of them have a new interface description over here. And this is showing exactly how we can use Yang Suite and, in this case, netconf to go out and configure our device, and specifically using Ansible. So we can, say, make many different hosts for our Ansible playbook. So we can run through many different devices within our network to make the same configuration changes. Now, we were talking about netconf in this specific example, but is anyone using restconf today? Quick show of hands. No one is using it yet. Okay, well, we can talk a little bit about it today. Just as we were using netconf for device configuration, we can also use restconf as well. So restconf is using our REST-based API. Is anyone using REST? Maybe not restconf, but REST-based APIs? Nice, some of us are. Okay. So this is the typical HTTP or HTTPS requests here. And we can work with restconf as just another way to interface or talk to our device. So in this case, we'll again use a GET request just to start to figure out what's currently configured on our device. And in this case, we're interested in Cisco native. Okay, so everything that's currently configured. And we're going to narrow down specifically on loopbacks. So within RESTconf and specifically the REST APIs here in Yang Suite, we actually have this overview, this Swagger documentation. So has anyone seen this type of documentation for, say, like get, put, post, delete? I see quite a few of us. So you can actually work with your iOS XE devices specifically using RESTconf and these types of payloads as well. So you can do all of this using Yang Suite, and we're actually continuing to work today on making this Swagger documentation more accessible to you. So we'll have updates at the next Cisco Live for how you can even quicker and easier use this same overview to actually work with your REST-based APIs and iOS XE. So we've been talking a bit about configuration, and there are a few different ways that you can use Yang Suite to actually configure your devices at scale. So now let's talk about device monitoring. We have so far onboarded our devices, we've configured them, and now we're ready to monitor our devices. So before we get into this, is anyone using SNMP today for device monitoring? Quite a few of us are. Okay, awesome. So a lot of customers are using SNMP, and we've actually done some internal testing against using SNMP versus using our programmable interfaces, so model-driven telemetry. And in this particular use case, we were working with SNMP specifically to just collect interface. So all of our interface data we're getting through SNMP. Whereas for all of the other programmatic interfaces, we're actually looking at 17 different features. You can see all the details of them over here. And we're collecting it at a relatively aggressive rate, right? Every 60 seconds, we're collecting data on all 17 of these features. And what we found is over here in this table, basically regardless of which programmable interface you choose to get this telemetry data, it will always be taking up less CPU, less memory. You'll be getting more data and faster if you use your programmatic interfaces instead of using SNMP to get this same information. And just as a reminder, for SNMP, we were only testing getting one feature, interfaces, whereas for all of these other four, we were testing 17 different features. So we're seeing a big shift in the industry where customers are moving away from using SNMP and using towards model-driven telemetry. So let's get into that a little bit. Say, for example, you want to be like some of these customers and move away from SNMP and start using telemetry. Within Yang Suite specifically, we have some mappings, so from SNMP OIDs to Yang XPaths. So we're trying to make this easier and easier for you. So with each iOS XE release, we actually are over in the same place where we're looking at all of our Yang models. We're also releasing a CSV file, so as we collect more and more SNMP OIDs, we're adding them to this CSV file. So you can quickly and easily see within Yang Suite how to move from these SNMP OIDs to your Yang XPaths. So this is a quick overview of how to use Yang Suite to leverage this file. So say you go over to GitHub where we host all of our Yang data models, you download the CSV file, then you can quickly go to the Analytics tab, click on SNMP to Yang mapping here, and you can actually load up your CSV files, and you can explore to find which ones are actually available or mapped today. And you can do your own mappings as well. So we're trying to, again, just make this as easy of a process as it can be. So we were talking a little bit about telemetry earlier, and now we can double click on it. So what are the benefits of telemetry, or why would we actually use it? Let's take a quick look at a workflow here. So we have our iOS XE devices, and say we set up a gRPC telemetry subscription. So we want to push data from the box. We send it to Telegraph as our collector or receiver. So this will just format the raw data coming off the box into a way that we can quickly and effectively store it in, say, Influx database, our time series database here. So now that we are storing all of this data, we can then query it using a visualization tool such as Grafana. And the reason that we're talking about Telegraph Influx, and Grafana, or the TIG stack here, is because these are all free, publicly available open source toolings. So now that we're using Grafana, we can actually visualize our data in a really easy and effective way. So this will help us see when there are any anomalies. It will help us see if any devices are having maybe if any of our devices are an outlier, we can double click on those to go see where there may be issues within our network. So say, for example, we wanted to get our show processes CPU for one device. We can quickly and easily do that using the CLI. But if we want to get this at, say, a regular interval, and if we want to scale this up to many different devices, we can use telemetry. So if we're scaling it up to, say, 6 or 6,000 devices, it will be much more complicated. So if you want to get the status of your current device, you would need to go in and actually run this show command for every different device. And here we're showing how you can relate this CLI, this show command, back to a Yang model. So if we have show processes CPU, this is the data that we'll receive. Now we want to understand how can we get that same CPU data at a regular interval using Yang models. So in this case, we'll use the processes CPU opper, and again, operational is that read-only data. And we'll get all of the same data, all of the same information that we would from using the show command. We'll get all of that within the Yang model itself. So what does that mean? For telemetry, we can, instead of doing the show processes CPU for each device in our network, we can go in and create a telemetry subscription here. So you may say, oh, this is way more config than just doing a show processes CPU. And if you're thinking this, that's true. We've got like, what, 5 or 6 lines here for each device. However, this is a one-time configuration change that you need to make, because as long as your receiver or collector is up here, your device will continue to push that CPU data at the interval that you've specified. So you won't need to go in and change this configuration after you've made it or applied it to your devices. So again, we can see all of the telemetry data coming in, and we can completely customize how we want to look at that data. So here in this example, we're seeing that, okay, maybe for fan, what are we getting here? Fan temperature, okay, we're getting temperature on a stack. So 4 are looking pretty good, right? They're in the green. 1 maybe we need to double click on as it's approaching a threshold. And the other one is, okay, it looks like an outlier here. It's in the red. So we can use Yang Suite to actually build up our telemetry subscriptions by exploring our Yang models and looking at the XPath that we need. So again, this is doing essentially the mapping that we need here of how do we filter out the specific feature that we want to get telemetry data on. So this XPath and prefix here is directly used within the telemetry subscription that we apply to our devices. So again, we're using Yang Suite to help us set these things up. And then we're able to create completely customized dashboards like this to help us quickly and effectively see changes that may be happening in our network. One additional thing for Yang Suite specifically is you can actually use Yang Suite as a telemetry receiver. So in this case, we're using gRPC. We're pushing data, and we're using Yang Suite to actually receive it. So we're seeing the raw data actually coming in here. This is our process CPU utilization, and we're seeing at regular intervals this data coming in. So if you don't necessarily have a receiver set up yet to collect or store all of this data, you can still use Yang Suite to push the data out, and Yang Suite will in fact receive it. So next we can move on to device optimization. So now we have onboard, yes, question here?
Can I combine these periodical updates with event-driven updates? Like, so, if something above a threshold happens, will I get an update sooner than update next interval?
Okay, so the question is, what about the difference between getting updates on an interval, so periodic based, versus event based? So when does something change? And you can actually get both of these. Yes, you can get both using Yang Suite, your Yang models. It depends on how you set up the telemetry subscription itself. So in this case, we were just looking at periodic options, but on change is also an option as well. So if maybe there was a user logged in and that they failed the login, you can get an update on that specific action in your network too. So we can talk more about that offline as well. And using the same models, yes. Same models, but you'll set up a different telemetry subscription here. Great question. So next we can move on to device optimization. So is anyone using ping to check device reachability today? Quick show of hands. Anyone using ping? Probably most of us, right? A lot of us are using it. So this is a great tool to actually see if you have device connectivity. So we've recently introduced a few different Yang models called the live tools. And these can all be used to programmatically work with your devices. So we can send a ping, for example, programmatically. We also have MTR, throughput, traceroute, and wake on LAN. So essentially you can use Yang models to help with this additional testing that you may have. It's not just specifically on box, going out and configuring things or getting operational data from your device. You can actually get this additional information and do some additional testing as well using Yang models. So this is just a quick example of what it looks like to actually send a ping to a device programmatically. You can specify the receiver, so where you're pushing this out to, as well as the sender, so where you're going to and from. And this is just yet another way to work with your devices programmatically and ways that you can use Yang Suite to better understand how these processes work. So we have just about a little over a minute here, so I want to highlight a few resources to get started. So we're here in Cisco U, and actually if you go to Cisco U Online, you'll see we have quite a few different programmability and automation toolings that you can work with. And you'll notice that one here is for Yang Suite with netconf. So we focus quite a bit on netconf today. And then we have another one that's focused on Yang Suite specifically with RESTconf, and with gRPC as well. So both of these I would highly recommend if you want to get hands-on or start working directly with programmability and automation and Yang Suite today. We have had quite a few sessions throughout the week here, so definitely check out the recordings if you're interested or want to learn more about any of these topics. And we have a programmability website. So this includes all of the things like white papers that we have. We've released one that's specific to API in general. So this is going from day 0 through day end, device optimization like we've covered today. But it gets into way more details about how you can set things up in your own network. We've also recently released a Yang Suite Learning Lab. So this is through DevNet, and I highly encourage you to check that out as well. So this is available and accessible through developer.cisco.com/iosxe. You can check out our Yang Suite Learning Lab there. And if you haven't already, you can join the Webex space, and we'll drop this slide deck as well as all of the resources here. So thank you so much for attending, and have a great Cisco Live.
All right, can you all hear me okay? Awesome. Welcome to Thursday of Cisco Live. My name is Kyle Winters. I am a technical advocate focused on security in the Learning and Certifications group. And today I want to talk to you about malware. We're going to cover and give you an understanding of some of its tactics and basics, but we're going to start first with a brief history of malware and a better understanding of what malware actually is and the different types that are out there. Cover a brief history. It's not going to include every little bit of history that exists about malware, but just to kind of give you an idea of how it's evolved over time, and then compare that to the current malware landscape as well. Then we're going to cover common malware behaviors and techniques to give you an idea of how this malware is actually working. And then we're actually going to take a look at the Ryuk ransomware, sort of crack it open a little bit and kind of go into how it works to give you an idea of how a real piece of malware is leveraging all of these different behaviors and techniques that are common across malware in the industry. We'll close with just a quick summary on different types of tools that are available to analyze and defend against malware. Just a quick housekeeping item. Inside of the Webex, we do have a Webex team space for this, so feel free to join if you'd like, ask questions later on. I'll post some slides, the slides that we're covering today, inside of that channel as well, so you can access it. You don't have to worry about taking pictures or anything if you don't want to. Those slides will be available to you later. And one quick, fun, important disclaimer is that this is all for educational purposes. Please do not go and write your own malware, preferably, after the session. We intend this presentation for educational purposes, not to necessarily encourage you to build your own malware. So make sure if you are doing anything like that for some reason that you're doing it in an approved legal way. So just to kind of start really quick, what is malware for those of you who might not know? It's short for malicious software. It's really any piece of software that's intended to cause damage or disrupt systems. It's not the good stuff, it's the bad stuff, really put it simply. But the reality is that not all malware is the same. There's a lot of different types of malware that exist. And some of these terms you've probably heard before. You might think that they're interchangeable, but they actually have different meanings. So for example, a virus is a malicious piece of code that attaches itself to a clean file and spreads to other files. It can do things like delete files, disrupt systems, cause operational issues. You've also got worms, which is a standalone malware that's really intended to replicate itself and spread to other computers as quickly and effectively as possible. Trojans are ones that consider like the Trojan horse, designed to look like legitimate software, but it's actually malicious software under the hood. You've got things like ransomware as well that are encrypting files and demanding ransom to decrypt those files. Spyware that's monitoring user behavior and sending that upstream somewhere. Things like adware as well too that can display unwanted ads in the browser. So, these are all different types of malware. They don't all function the same, and they don't all have the same intended purposes. Now, when it comes to kind of the life cycle, the typical life cycle of a malware attack, there's several different phases to it in most cases. It starts with reconnaissance, where they're going to be gathering information about the target that they intend to attack. Then becomes that initial infection or the delivery of that payload. It can be done through phishing, some kind of exploit, drive-by downloads. We'll talk a little bit more about those here shortly. But once you have that initial infection, really execution becomes the next phase, which is running that target payload of that malware. From there, usually malware tries to establish persistence so that way it can maintain a foothold inside of whatever system it's compromised. And then it does things like command and control function. So it can communicate from that infected host out to some kind of malicious actor who's controlling these different types of devices, telling the malware how to behave. And then from there, it can also oftentimes move laterally to other devices as well. Worms are very good at doing that. But the more devices that you infect, the more damage you can cause. Oftentimes, they try to do things like privilege escalation as well. So it might be running initially as whatever user it can gain access to, but it's going to try very, very hard to get to root privilege so that way it can get as strong of a foothold and do as much damage as possible. Oftentimes, once it's done all of this, there's usually some kind of action or objective that it's trying to achieve. Maybe it's data exfiltration. Maybe it's what a piece of ransomware would do and encrypt and hold up a ransom note. But oftentimes, very common one, let's just say for this example, is data exfiltration. It's going to try to extract data out, and then it's going to try to clean up after its own tracks so that way people don't recognize and can't catch it as quickly as possible, don't realize that they've been compromised. So this is kind of the typical life cycle of a malware attack. And just to kind of lay it out a little bit differently, what an attack sequence might look like It might start with a well-tailored email. Maybe it's a spear phishing attempt, which is targeting a specific individual to gain access into their system. From there, though, it's going to essentially, when you click on that link in an email, make a DNS query to a questionable site, potentially malicious site, to get a piece of malware or some kind of file to download. It's going to essentially start some kind of strange process in the back end to get the necessary information that it's looking for. And then it's going to, once it's installed that piece of malware, do its necessary payload process. It might look for other devices out in the network. It might try to steal data, as an example. So this is just an example of what one attack sequence might look like. So a brief history of malware. This is not going to be a full holistic history, but we're going to cover some key points really quick, just to kind of give you an idea of how malware has evolved over time. Really, it kind of starts in 1988 with the Morris worm. This is really kind of the first known piece of malware that exists. And you can actually, that's actually it on that floppy disk right there. It was created by this man, Robert Morris, from Cornell University in the United States. And what it did is essentially exploited a bug inside of SendMail to be able to replicate itself and spread across systems. Now, at the time, it spread to 6,000 computers, which in 1988 was actually a significant amount of computers. So it disrupted universities and military sites through this. It was really kind of the first worm that came out that was known publicly, and that kind of started this whole malware trend from there. So a pivotal moment, to say the least. But over time, malware began to evolve, and we jump forward to 2003 with the SQL Slammer. This one spread rapidly across the internet. It exploited a buffer overflow in Microsoft SQL Server, and it sent essentially small UDP packets to random IPs on a specific port. In about 10 minutes, it infected 75,000 devices. So it spread very quickly. It did things like disrupt ATMs, airline ticketing, emergency services, and they estimated the damage from this to be about $1 billion. So at this point in time, it became clear, like, there's now an importance to make sure that you're regularly patching and updating your systems to avoid these types of bugs that can exist, these exploits. Moving forward to 2007 was the Zeus Trojan. This one is essentially done through phishing emails and drive-by downloads. It was exploiting browser vulnerabilities, and it bundled in exploit kits as well as part of it. Essentially, it stole banking credentials and used keystroke logging to disrupt essentially the financial institutions around the world. It also created botnets and did distributed denial of service attacks as well. So it led to ultimately the theft of millions of bank accounts, millions of dollars from bank accounts. And this was kind of a pivotal moment where now we're taking an approach less from disruption, more to financial incentive. So an interesting kind of shift now occurring in malware. People are seeing this as an opportunity to make money. And even further kind of shift that occurred as well too was in 2010 with Stuxnet. This essentially impacted industrial control systems in Iran. It was believed to be done by nation-state actors. So this was kind of now a pivotal point where malware is being used to essentially wage warfare with other countries. It targeted these Iranian nuclear facilities, and it helped essentially to destroy about 1,000 centrifuges through the infection of these industrial control systems. So now malware is not just being seen as a financial means to gain money, but a means of warfare as well too. Cyber war essentially now becoming a more household topic. You've got Emotet as well. That came about in 2014. And this kind of took things a little bit further as well, diving into leveraging multiple pieces of malware and combining those together to achieve different outcomes. Really, this one was about financial disruption as well too. But this was very unique in the sense that it was leveraging multiple different types of attack vectors, becoming a lot more complex, these pieces of malware. And we take a look further now to the WannaCry outbreak that occurred in 2017. Really, this was a very disruptive one. I'm sure we all remember when this occurred. This was also leveraging multiple different vulnerabilities that occurred, but now encrypting essentially everything on a device and demanding ransom out of it through Bitcoin. So Bitcoin now becoming more popular as a means for ransom. It essentially became very easily widespread at the time. So it was a very disruptive piece of malware. And as we shift forward now into 2020 and the 2020s era, we're seeing more things like supply chain attacks that are happening. The SolarWinds one is a great example where the software supply chain was essentially attacked itself, and that was leveraged essentially to install malware and backdoor capabilities. It unfortunately affected about 18,000 SolarWinds customers, including US government and major firms. And it resulted in quite a bad data breach as well too. So things shifting now more into the supply chain as well as part of this. When we take a look at the current landscape of malware, there's a couple of key trends that we're seeing. It's certainly increasing in its sophistication. Modern malware becoming more sophisticated. It's employing more advanced evasion techniques such as polymorphism, fileless attacks. I've even seen some zero-touch attacks as an example where you don't even need to touch anything. All of a sudden you're infected just by receiving this message. These attacks are becoming more targeted as well too. They're aiming for specific industries, individuals, organizations. A great example of some malware specifically targeting the healthcare industry as an example because they know that that's a particular weak spot in often cases. And we're also seeing a trend of malware as a service, this underground black market that's emerging where people can purchase malware to be done on their behalf. A great example is ransomware as a service where criminals can essentially order ransomware to be delivered to whatever target they want and reap the rewards and split the profit with whoever initiated that attack on their behalf. So these are becoming more sophisticated, more targeted, more accessible, and they're also becoming more frequent. I mean, this is just an example of from a few years ago, but the number of different vulnerabilities and attacks that are being leveraged against those vulnerabilities are rapidly increasing over time. And if we take a look at how security operation teams are facing this challenge, 51% of teams say that they're struggling to detect and investigate these advanced threats. 66% of them were affected by malware a few years ago. 55% of security teams say that critical alerts are being missed. You can read some of these statistics for yourself. There's a lot to it, but one important one, the average cost of a cybersecurity breach in 2023 was $4.5 million. Now, I know for a fact that, and I don't have the statistic up here right now, but when you increase your detection time, that number can go down. But as your systems and your organization becomes more complex, that dollar amount goes up as well too. So this is an increasingly growing problem. And if we take a look at the global cost of malware attacks by this year, we're looking at $10.5 trillion globally. So this is a huge business for the bad actors out there, and very important for all of us here to understand these pieces of malware and be able to effectively disrupt their attempts to disrupt us. So, this is obviously an important, costly thing. If we take a look again at the landscape for security teams, 62% of them, let's see here, 62% of incidents were committed by organized crime as an example. I'll let you read some of these statistics, but an important one is on the end there. 2,000%, 2x essentially. Using manual flows is a lot more ineffective versus automated flows. So leveraging automation and technology to understand these things and detect these things is really what this is all about. That gives you an idea, though, of kind of the current malware landscape, where malware has come. We all have a base understanding now of malware. Let's actually dive into some of the different behaviors and techniques that many common pieces of malware use. So we kind of covered that chart initially, and let's dive into it a little bit further. We'll start with that initial compromise, and that can be done various different ways. It could be a phishing attempt. It could be a drive-by download where malware is downloaded and executed automatically when you visit a website. It could be done through exploiting vulnerabilities or malvertising, which is advertising done through malware. A great example of that we got two up here. The first one is phishing. Hopefully you're not going to click on that link because that's going to take you to a bad place. That's not a legitimate PayPal email, unfortunately. But does anybody notice anything going on this screenshot on the right here? KeyPass, it's a popular tool. Would anybody click on that link? Good, nobody raised their hand, because if you actually were to take a look at that link a little bit closer, you'll see it's actually not KeyPass's website. It's using a different character there for the K, and essentially trying to trick somebody into clicking on that link instead of their actual website. So some of these malicious actors are buying ad space on Google, like you see right there, to essentially trick you, or whoever it may be, into downloading malware instead of legitimate software. Another tactic that a lot of malware uses is code obfuscation. So this can be done various different ways, but ultimately the idea of this is to obscure the source code to make it difficult for somebody who's looking at it to understand what this is doing. It could be done through encryption as an example, so encrypting the source code in a way where you can't read it. It can be done through encoding, like base 64 encoding as an example. There's a lot of different ways. Polymorphism is another one where the code actually changes on its own and changes its behavior every time that it's run and executed to that way trip up any kind of detection system or static scanning that may be occurring. So there's a lot of different ways that it's doing this. This is an example here where this essentially decodes to that piece of code over there. So when you look at this, this looks a bit like gibberish. It doesn't really make a whole lot of sense. But when you've deobfuscated it, it's actually clear that this is actually a piece of malware that is trying to do something malicious. So it's a lot of interesting ways that they can try to cover their tracks. They also, one common thing that malware oftentimes does too is persistence. So it wants to maintain a foothold in an organization inside of a system for as long as possible. And there's various different ways that it can do that. One is through modifying registry keys. It could be setting up cron jobs and tasks as an example, SSH key abuse, or installing rootkits. These are all different ways that malware is able to set up persistence. And in this particular, we got a couple examples here. One's of a registry key that's been modified. And this one down here is a cron job that was set up to essentially initiate a reverse shell every minute to a remote host. So that's a way for somebody to then maintain their foothold and access that particular system that is compromised on a regular basis. Lateral movement is also a common pattern and behavior of malware. It's really trying to do things like abuse remote desktop as an example, SSH. It's trying to move laterally, maybe access credentials from somewhere so it can access other additional systems. This worm-like behavior can be very common in malware. In this particular example here, it's essentially scanning the network, looking for different hosts, and for each host, it's going to try to open up a thread and exploit that host in its own unique way to gain access to it and spread further. Command and control is also a very common one as well. This is the ability essentially for somebody remotely to communicate back to that system and give it instructions, give that malware instructions on what to do. There's lots of different ways that it can do this, leveraging HTTP and HTTPS as an example. DNS is another one. A very interesting one, though, is social media platforms. So I've seen malware where it actually is looking out to Twitter on a regular basis to a specific Twitter account. And when that Twitter account posts a new tweet, that tweet actually contains instructions for what that malware needs to do next. So it's very kind of clever how you can leverage a system like Twitter to be command and control server essentially for you and communicate out to these clients. Data exfiltration, also very common. There's lots of different ways that data can be exfiltrated. Key logging is one example, screen capturing, file exfiltration using things like HTTP or FTP. In this particular example, it's actually using DNS to exfiltrate data. So it's got essentially a malicious DNS server here. This is owned by the malicious person, and it's doing a DNS lookup for this particular web address. But this is actually essentially a base 64 encoded string that is essentially containing a bit of data. So they'll essentially take the data, encode it, and make a bunch of these little queries and then stitch that data back together, and now they have their exfiltrated data. And they're leveraging DNS to do this to try to avoid detection and make it seem like it's just a normal DNS queries that are going on the network. A couple more to cover for you: destruction and disruption. So this can be things like ransomware encryption, data wiping, denial of service. Really, this is just essentially trying to destroy things, disrupt, cause as much harm as possible. Maybe you don't have a particular end goal, or maybe you do and you want to leverage it to hold a ransom. That's where that destruction and disruption technique can come into play. And evasion techniques, another one as well too, ultimately trying to cover your tracks. In this particular example here, it's trying to determine if something is a VM or not based off of the disk size of it. If it's got a very small disk size, this piece of malware thinks that it's a VM and it's not going to execute, essentially. But there's essentially other ways that they can try to do evasion as well, such as log deletion, delaying execution, lots of different ways there, but this is just one example. So that covers some common techniques and behaviors. And let's take a look at an actual piece of ransomware here, the Ryuk ransomware. This was first observed in 2018. It's believed to be associated with a criminal group linked to Russian cybercrime. And it was very disruptive. I mean, it took hundreds of thousands and to millions of dollars of Bitcoin, essentially, in its process. And we'll kind of cover a little bit of that here right now. But to give you an idea of the attack chain of this malware, it really started with a phishing email. When you opened up that link, it was essentially a doc that ran a macro which launched a PowerShell script. That PowerShell script first downloaded Emotet, so it's leveraging another piece of malware initially first. Emotet then grabs and deploys some additional pieces of malware, such as TrickBot. It pulls that in and leverages that to essentially disable antivirus services, harvest data, steal credentials, and then the command and control piece that it communicates with through those different pieces of malware then pulls down the Ryuk ransomware virus itself, and from there does the encryption and the ransom process. So it really starts with that dropper. When you click on that link, that's where it begins. It contains a 32 or 64-bit payload depending on the system that you're using. So it'll actually use the is-wow64 process API to determine if it's a 32 or 64-bit system. It'll also determine whether or not it's Windows XP or Windows Vista or later, and then act appropriately according to that. But once it essentially triggers that process, it runs into a shell and executes some additional commands. So it tries to create persistence, essentially by utilizing a very common registry key. So it creates a new value for that registry key, and it sets it to be executed on a regular basis. So that way, when you just turn off your system, it's able to run on a consistent basis there. Once it's established that persistence, it's going to try to use some common functionality to escalate its privileges. So it uses an adjust token privileges function to essentially modify the process and the security access token that it has available to it. And it tries to set its permissions to this SD-debug privilege. So that's actually a privilege on a Windows host that has a bit more elevated privileges than your standard user, and it's trying to leverage that essentially. Intended purpose of it is to allow for debugging and memory adjustments of processes owned by other accounts, but it uses that in a particularly malicious way. So that's actually one that's commonly used by malware as well too for process injection, but that's what this Ryuk ransomware is also using here. And once it has that permissions, it then does its process injection. So it enumerates through the different processes that exist on that particular host. Once it finds its selected one, it essentially attempts to set the SD-debug privileges rather, to adjust that to insert a process into there. So it's using the open process API. It's retrieving kind of what the current payload it is, and it's actually allocating the exact memory necessary to that specific process to run and inject itself into that process so it has enough memory. Is essentially inserting itself into an existing running process, if that makes sense, and runs inside of there to ultimately avoid detection. So very sophisticated way of doing it. In the process, though, as well, it also goes and kills a bunch of other processes. So that could be things like antivirus software, as an example. It really iterates through and essentially just takes, it kills 40 different processes, 180 different services. It's looking for things that could disrupt itself and ultimately detect it. So it's going through, it's using these net commands, SC commands, task kill, killing all of these different things, starting its essentially its disruptive process. So it'll begin by killing those processes. Then it'll also go a step further and delete backups as well too. So many Windows hosts have shadow backups that are occurring on them on a regular basis. The Ryuk ransomware is actually going to go through and delete all of those, so that way you can't effectively back it up, and you're more likely going to have to be forced to either pay that ransomware or just give up on that system as a whole. So it deletes those backups, then it begins the encryption process. So it uses a multi-threaded encryption process, so it's incredibly fast. It's handling each file individually in its own thread, so it moves very, very quickly. There are certain types of files that it does try to avoid, like certain executables as an example, but it tries to encrypt everything else. It uses 256-bit AES keys for each file, and it essentially splits it up into chunks of 1,000,000 bytes each. So each of these is being kind of chunked up a little bit based off of those 1,000,000 bytes. And interestingly enough, I don't know if you can see this very well, but right here, it says the string Hermes. That's actually a unique signature for the Ryuk ransomware. And it puts that little kind of key metadata tag at the beginning of each of these encrypted files. So if you are compromised and you take a look and try to crack open one of those files and you see that Hermes line at the beginning of it, that's a good indication that this is the Ryuk ransomware. Not only does it encrypt files on your system, it also tries to go out, communicate with network shares, and encrypt files on those as well too. So it's not just disruptive to your system, but anything else that it's connected to, it's going to try to go out there, have that kind of lateral movement worm-like behavior, and encrypt and do as much damage as possible. Lastly, before it gets to that ransom note, it establishes command and control functions using HTTPS to communicate back. It doesn't communicate as often as some other pieces of malware do. This is by design to ultimately try to avoid detection as much as possible. And once you've done all that, you now have your ransom note here. This is essentially going to tell you got to pay Bitcoin to this particular address here if you want these things to be decrypted in time. So that's really kind of how this piece of malware works and how it kind of leverages its different phases and behaviors over time to get to its end goal, which is to extort you for money. So how do you defend against these particular types of malware? This one in particular, patching your system is a great first step, making sure that you don't have the vulnerabilities on your system to be able to have that exploited. Network segmentation is also a good idea as well, because if you have a segmented network, that's going to mean that things are less likely to spread across to other systems. Having strong backup strategies is also important, leveraging multi-factor authentication, and having a good endpoint detection and response solution. Now, Cisco does have a couple tools for malware analysis. I'm going to breeze through this fairly quickly because we're getting short on time. But the first one is Cisco Secure Endpoint. This runs on your endpoints and is a great way to detect malware. One of the unique things about this is that it does have Cisco Malware Analytics on it. So it can essentially analyze malware and tell you if any piece of software is malicious or not. Very valuable tool to have. It'll do things like static and dynamic analysis of particular files as well. Cisco Secure Email is another useful tool. Many pieces of malware start with the phishing email, so having a strong email solution can help you in your strategy to defend against malware. This will also leverage, do things like URL reputation scanning, file analysis, looking for malware. Cisco Secure Network Analytics is another one as well too. You can detect things like reconnaissance that are occurring in it, command and control behaviors, data exfiltration, very valuable tool. And one last one I'll mention is XDR. This is for extended detection and response, a very valuable tool as well. It leverages Talos as well as some of these other tools do. combines all of these tools that I've mentioned earlier into a singular platform to do and manage your detection and response when malware events occur. And you can get all these things together, fortunately enough, in Cisco's breach protection suite. They all come bundled up together there, making it really easy to have a strong defensive posture against malware. So unfortunately, we are out of time, but I do appreciate you all today. We did cover quite a bit very quickly, going into malware, covering kind of what it is and the history of it, going into what some of the common behaviors and tactics of it are, as well as actually taking a look at some of the source code for an individual piece of malware. If you're interested more in ethical hacking and how malware works, I highly recommend that you check out the Cisco Certificate in Ethical Hacking. It's available, a free course of about 70 hours of content on Cisco Networking Academy. That's netacad.com. And you can learn a lot about red team activities. The course itself is free. For a couple bucks more, though, beyond free, you can access these Capture the Flag challenges and be able to get a certificate in ethical hacking from Cisco that's valid for the rest of your career. So I highly recommend that you check that out. I highly recommend that you also check out the Cisco Breach Protection Suite, as well as Cisco U, the namesake of our theater here. It's a great learning platform to learn about these different types of things. We've got free tutorials on there as well. It's free to sign up, so you can learn all sorts of different things on there as well too. But I want to thank you all for your time today. If you get a chance, please fill out the session survey. You get this awesome limited edition Amsterdam t-shirt here if you do 4 surveys. But more importantly for me, your feedback is very appreciative, so I can improve this session over time and make it better for all of you as well. So feel free to continue your education, check out the demos, capture the flag, have a great time here at Cisco Live, and enjoy the celebration tonight too. Thank you.
Good? All right. Welcome, everyone. I appreciate you coming in here and with a competition of lunch. I know it's a little tough here, but I appreciate you coming in here, joining me, talk a little bit about Webex Contact Center and programmability. My name is Adam Weeks. I'm the manager of Webex Developer Evangelism, and we like to help developers build and educate all of our customers and developers on the Webex developer ecosystem. So what we're talking about today, we're going to be talking about a little bit about the product with Webex Contact Center, how we're going to go about building on top of Contact Center, or how we can build inside of Contact Center, and then also we're going to talk about getting started and how to actually get started building with Contact Center. So the whole purpose of Contact Center is to reduce this amount of time. So the average person spends 43 days of their life on hold with some sort of contact center. And what we try to do with Webex Contact Center is make that experience much better and shorten that time and get that experience a lot better. And we can do that through customization and programmability. So before we get started, I do have a Slido that I want to poll everyone, but maybe we can just, we've got a smaller crowd, we want to raise hands if you like, but I just want to know, are you a Webex Contact Center customer? So if you are, we can go ahead and scan that code. The Slido should be open in the event app as well if you want to go directly to it. Trying to find out if we are a Contact Center customer or partner, or even just a user of Contact Center. All right. Got a nice little mix between Contact Center. So since we have some people that are not Contact Center customers, we'll go over just what exactly is Webex Contact Center. So Webex Contact Center, the whole flow is that, the main flow is that you have a user, a customer calling into your contact center. You're going to go through what's called the IVR, which is the interactive voice response flow. And that is when you call in and you get prompts about entering 14 your customer support, 2 for sales. Those types of flows you're able to configure those types of flows, pull data in as well. That's through the Flow Designer tool that we have for Webex Contact Center, which is a drag and drop, low code, no code tool that allows you to do those customizations. Once your user goes through that full IVR, then when they want to talk to an actual person, an actual agent, we have that queuing system. So they go through the flow and they can get into that queue to get in touch with one of those agents. Once that agent answers the phone, they have what we call the agent desktop, or the admin desktop, the contact center desktop, that allows that agent to have information about that customer that they're talking to on the phone. So they don't have to repeat anything that they may have entered in from that IVR. So if you've had that experience where you've called in, you've typed in your account code, and you've selected what your problem is, and then you talk to an agent, and they have no clue what's going on, and you've got to repeat yourself and tell exactly the same story you just did. That's what this whole flow and that agent desktop is supposed to help with that experience and help you reduce that and give that agent the context for why the person's calling in. We also have the ability to send out post-interaction surveys. So once the person is done and the agent has handled their issue, we can post and send a survey to them and get that customer satisfaction rating. So we understand which agents might be performing better or worse, and how we might improve that customer experience for our customers that are calling into the contact center. So as you see, that whole flow starts with the customer calling in and ends with that survey. And that's the entire flow of that customer journey for Webex Contact Center. Now, what we like to see here next is how do we go about customizing these things? We don't want to just have a basic contact center, but we may want to have interactions with other systems and other data sources that are not in the contact center. And that's where the contact center for developers comes in. So next Slido for us. I want to know if you are a developer, or even if you consider yourself a developer. So I've got 3 options here for yes, I dream in assembly. No, but my coworker is. Or I know enough to be dangerous. All right. For those of you who aren't developers, I'm going to show you that you can be a developer today. And if you don't want to, please tell your developer about the stuff that you learned here. All right, just a few more minutes here. All right, great. So what does the Contact Center Developer Platform allow you to do? And it allows you to customize every step of the way. We have things that allow you to build dashboards. You can track KPIs and reporting. And you can also integrate into, if you have existing business applications that you want to integrate that data into. So like I said at the top, we're going to do three different things. First, we're going to talk about how you can build on top of the Contact Center API data with automation and scripting. We're going to talk about building in Contact Center and how you can integrate your data into Contact Center or even pull in views to your Contact Center. And then I'm going to give you some tools to get started with sample codes and things about our developer portal and sandboxes with the build with section. So starting off with how to build on the Contact Center. And this is what we're talking about here with customizing our wallboards. We're going to do some custom agent supervisor reporting. We got APIs that you can pull in, automate some of your processes where you don't have to log into Control Hub and manually do some of these things that are bulk administration tasks that take up a lot of your time if you've got full lists of data. And we can do that with our APIs. But what I want to start off with is, since we don't have a lot of developers here in the audience, I want to just create a baseline here of what actual APIs are. And so when we say API, we're talking about an application programming interface. So this is the way computers can communicate with other systems. So for example, in this, we have a Webex Contact Center. that we want to reach out to our order processing system, which may not be on the same platform as Webex Contact Center, but we need to get data in and out of that. The order processing system actually talks to our customer database. And then we also go back to Webex Contact Center. So all of this intercommunication between these systems are done through things called APIs, that programming interface. So what type of APIs does Webex Contact Center have? We've got a ton of different things. I'm not going to go into each one today, but I'm happy to talk about any of these that you'd like to see. But just starting off, we've got configuration APIs. So this is the things that when you're configuring your contact center, things like business hours or sites, anything that you can do like with a Webex Control Hub where you're going in and configuring, we have APIs that can do that automatically. So if you've got customers with multiple sites and multiple different business hours, and all that data is tracked somewhere else, you don't have to have an admin go in and manually configure, go click site 1, these are the business hours, site 2, these are their business hours, but instead you can write scripts to communicate with our APIs and send that data over. We also have contact control APIs, which allows you to control as those contacts are flowing in through your IVRs and send them to specific agents. We've got data and reporting APIs that we're seeing a lot of customers use to build custom reports and dashboards to see how their contact center is working. We also have media APIs, so you're able to pull in, if you want to pull in some of those recordings afterwards and see and analyze customer sentiment. We see a lot of customers doing that. They're pulling in those reports and they're pulling in the recordings from the calls themselves and analyzing and using AI to analyze those calls. Then finally, we also have real-time events with our webhooks and WebSockets that you can actually program your applications to react to interfaces that are happening in real time. So as these events are coming in, if you want to proactively monitor, if you want to proactively report that, so say a queue is increasing in time and you have too many calls in the queue, you can kick off an API call to your system to send an alert out that we need to bring more agents back online. Next side we're going to go into is the Webex Contact Center building in. So talking about how now we are pulling that data out and interacting with Contact Center, but now we're going to talk about how we're going to bring our app into Webex Contact Center. And we have quite a few different methods of doing that as well. There are agent desktop widgets. We have CRM connectors, so if you're using things like Salesforce, we have those connectors for you. And we also have some data connectors within our Flow Designer that I'm going to talk to you about. So first off, that desktop customization. So when I was talking earlier about that agent desktop experience, so when the agent logs in and can see the information about the customer that they're talking to on the phone, that's done through our agent desktop customization. And on this side, we have, so right here, this is our entire agent desktop. We've got a few different areas that you can customize. The most basic being the title and logo up at the top. You can change it to your own. We have this header, the header area, which is just a permanent space for information. You can see like the over here on the side. Oh, the laser's not working. Over here, you can see the agent is available. We've got the main workspace, so this is where the agent is living and breathing and working in all day. And then we also have this navigation bar, which we can change and add some pages if there's things like documentation that you want to add in. Go a little bit deeper detail into that agent desktop experience. So these header widgets are things that are just are prominent for your agent. We've seen things like they're monitoring the actual capacity of the contact center. We actually have some sample code that shows how you can put it like an RSS feed. If you want to just have company news up at the top, so if you want to have some information that's important to your agents so that they can read up and keep up on, that's done through the header widget side. The next is that navigation. So that was over on the side where you can add multiple different pages and have them go in. So one example that we have here that we're seeing here on this screen is the custom address book, where if you don't have, you can get the agents quickly access to that information that they need. and switch over directly to these pages, and you can build these pages directly for your agents. We also have what's called persistent widgets. So these pop up as an agent gets on a call. So when an agent gets on a call, if you want them to look up some information, if you need to have them reach out to your CRM and you don't have a connector built for it yet, you can add like a web view into that information directly on there. So when agent gets on a call and they have the person on the line and they need to look up some information for them, you can have that available for them really quickly. Then we also have what's considered headless widgets. So headless widgets do not have any sort of UI for the agent themselves, but we are seeing we're seeing it where you can send that data over to our CRM. So one of the biggest things that we're seeing that being used for is, on the screenshot, is our Salesforce connector. So the data, when the agent gets on the call and they have the contact information for who's being called, that information will be sent over to Salesforce through our headless widget using our SDK to populate that information within Salesforce. So the Salesforce has a tracking of that customer record being called in already. You can also activate screen pops for your agent. So the screen pops come up and we'll show that data like we were talking about, that persistent widget, but you can do what's called a screen pop, which is a little bit different, but you can have that automatically pop up for your agent as well. So yeah, we're seeing the headless widgets being used deeply with those CRM connectors. We had time here. All right. Next, we're going to talk about Flow Designer, and that was that IVR flow builder that we had. So this is our low-code, no-code solution for building out those prompts. And I'll give you a quick little tour of Flow Designer, the different parts of it. So the very first one is the top, where you've got your navigation bar. You can edit it. You can turn it into edit mode or just a view mode. Change the name of it. Some of the basic details on the flow itself. At the bottom, we've got all of our autosave toggles. We've got validation. We have the ability to publish our flow when it's ready. We even have a tool called a debugger. So once your flow is active and you start getting calls in, if something's not working properly, you can go into the debugger and actually see all those calls that have come in and maybe see what went wrong and how you might be able to customize and optimize your flow. Over here on the left side, we have our activities. So these are the things that you can actually drag and drop into the main area. So you've got different things like we can play a message. You can put them into that screen pop that I was talking about, some things on here. You can tell it to queue to an agent. We've got our virtual agents up here. You can even have it disconnect the contact when they're done. There's a lot of different activities. And we also have there's one that's not on here that we're going to go into about dipping into data in just a second. This is the main area. So this is where you're building that flow and allows you to visualize and drag and drop that flow. So if you've ever done any sort of IVR programming in the past where you might be writing shell scripts or Fortran, if you've been working on IVRs for that long, you might have to do some of that. This is much easier way, much visual way of being able to see that programmability of your IVRs. And then on the right is our settings panel. So these are where you'll go in, select an item, and then you can change the settings for each item. And so that's where you'll be doing most of the work. Once you drag these things onto the main area, you'll be able to customize it on that side. Oh, go back real quick. I wanted to call out one thing as well that on here. So this flow is for a new phone contact, so as the person is calling in. But there's also the idea of what's called event flows. So the event flows happen for different events that happen within your contact center. So you can have it so if when a person not just when a person calls in, but if an agent logs in, if you need to have a flow, or even if the contact gets disconnected, that's an event. So you can prompt that for that feedback. You can use those event flows there. there's a lot of different ways we can go about configuring and maintaining our flow designer and expanding on it. I'm not going to go into these today because I don't have 2 hours, so I only have 30 minutes. But just take a look at some of these things. We've got things like variables that we can set for each one of our activities. We've got output variables. These are the things that you're going to take. You're going to use that information in your flow to populate and configure that flow going forward. We also have an expression builder, which is like a templating language that allows you to modify your parameters. And we also have the speech synthesis markup language. So if you're using text-to-speech and playing the messages, you can configure how the system reads out items. So things like currency. If you want to tell it to read an item out in the currency, you might want to say 33 euros instead of saying EUR33. If you've ever called in and had like a text-to-speech sort of analysis that comes out, it just reads it directly as the string is written. You can customize that and give it a more natural, human-like feel to those virtual text-to-speech. Then we also have these. Oh, that's what I was talking about. Yes. So that's what's done. That speech synthesis markup language. So yeah, like I was saying, like the EUR. So you can say as interpret as currency. If the data comes back from your database as EUR 263.56, it actually, when it will read out, it'll say 263 euros and 56 cents. Got a little ahead of myself there. So we also have the ability to data dep into things like our CRMs. So if you're calling in and you want to get an agent's, your contact who's calling in, and you want to get their SLA priority, perhaps, and say, oh, this person has a higher SLA, so when they call in, we need to promote them to the top of the queue instead of the bottom of the calling queue. That's how you can do that. So you can actually, we have what's called an HTTP request activity. They'll dip out to our CRM, pull that information in, and bring it back to our IVR. You can also get those variables and pass that on to the agent. So then the agent even knows that information. So it's not just contained within your IVR, but you can send that over to your agent. And so the agent knows the priority of that customer while they're talking to them. All that data dip is done through an HTTP activity, which is what you drag onto your flow designer. Builds, and it works with APIs. So different REST APIs. You can do different types of authentication. So if you have an authenticated API, we support basic auth and OAuth 2 authentication types for our API calls within that HTTPS activity. We support the main get, post, put, delete commands, and the different content types for JSON, XML, and file. So no matter what kind of API that you have that you're going to be communicating out to, the flow designer should be able to connect to. I did want to call out one new feature that we've got, speaking of authentication, is that a lot of the things that we do within our flow designer reach out to our main contact center APIs. So one example flow we have is that if a caller calls in and they've just recently spoken to an agent and they get disconnected, when they call back in, the experience you usually have is that you get connected to a completely separate agent, and you've got to explain your entire process and the problems you're having again. And instead, it would be better if that person was routed to that agent that they just spoke with, right? And then that agent says that has that context and knows what they were talking about. So that's how we can use our APIs on the contact center to look through and say, which agent did this customer call in and speak with just recently? And we do that through our contact center APIs. Well, before this feature came out, you had to create your authentication scopes and tokens all on your own manually. You get your bearer token and your refresh token, and you've got to keep it constantly refreshed and updated. But the product team decided at Contact Center is that, well, we already know who these people are. We know you're a contact center admin. We are Webex. we don't really need you to have to maintain these access tokens on your own. You don't need to spin up a server just to maintain access tokens for your IVR to access our APIs. So now we have a special connector, which is called the Webex Contact Center HTTP connector authentication. So that's set up. Once you get that set up, you'll use that connector for the authentication, and then you don't have to maintain those tokens. You don't have to spin up any servers. Webex automatically knows who you are, and you can use that connector to pull in all of our Webex Contact Center API data. Here's some information about those screen pops that I was talking about. So this is that screen pop that we were telling to pop up the information to our agents. You can tell it to send it to a URL and customize the parameters. So one example we have is that a form gets filled out for that customer when they call in. If we already have that customer's information, there's no reason for the agent to have to recollect that information. So we can send that data directly to the web URL and have it pre-populate those forms for us. And then the agent only needs a few extra details instead of having to collect all the information again that the system already has. So now that you've seen everything that we've got so far on Webex Contact Center, I'd love to see what you are interested in. What are you interested in building with, and what piques your interest? So we've got those going through. We got those configuration APIs. So that's the things that replace the Control Hub administrative actions. CRM integrations. Yep, that's with like our Salesforce. Real-time webhooks for analysis. Desktop customization. Yeah, one thing about that desktop customization, we have over 70% of our Webex Contact Center customers are using some sort of agent desktop customization. So instead of getting it just as it is out of the box, they're adding on different customizations. So we're really excited to see all the different customizations and making the contact center work for you. Reporting APIs, yeah, dashboards and wallboards are huge to now analyze your contact center. All right, great, thank you. Now, next. What are we going to do next? I'm going to give you some actions to take home with and get started with building with Webex Contact Center. The first place you're going to go is our Webex Developer Contact Center portal at developer.webex-cx.com. That's going to have all the documentation that you need to get about our APIs and all those tools I just showed you. You'll be able to go onto that site and get some information, but also the most important thing to get started with is our developer sandbox. So if you're like me and you start playing around with your production environment, don't take the production environment down by trying to publish a new flow, because you might get a call from your IT department asking why you're doing that. Instead, we give you a developer sandbox that allows you to test out things on your own. And actually, it comes with its own PSTN line and routes and flows set up for you. So you'll have it, it's ready to go. And I believe you get like 10 licenses with it, but you'll have your own sandbox, your own contact center org for you to test out your development on. You don't have to work on your production environment. Next thing I want to point out is the new flow templates that we have. So when you go into your flow designer and you're creating a new flow, we have a ton of new flow templates that may already match what you're trying to do, or at least really close to what you're trying to do, that gets you a good starting point. So these flow templates are available for you when you go in and create a new flow. I do want you to monitor. We do have an API changelog on the developer portal. So if you're utilizing our APIs and you're looking for new and improved APIs, we have an API changelog that you can subscribe to with an RSS feed and understand what's going on there. We also have a developer community forums where we have our developer support, other contact center customers, product managers, and engineers that are all on, communicating and having conversations about problems or ideas that they would like to do with Webex Contact Center. Utilize the Webex Contact Center APIs label to filter that down. Or if you're a Webex platform customer as well, everything the Webex developer related is in the community forum. We also have an incredible developer support team that's available for you when it's any of your developer questions as you're building and integrating. So you can reach that developer support team from the developer portal or via email and creating those requests for our developer support team. They will interact and help you get your process going. So once you build those integrations, if you want to see, if you have that integration, you think maybe it might be great for other Webex customers, or if you're a company that's providing some of these integrations, we do have what's called the Webex App Hub at apphub.webex.com that allows you to publish those apps available for all Webex customers. So you're able to get in there and get your app in front of other Webex customers. I also use this as an idea portal to see what other people are building and what other tools are available out there. If there's a process that you're trying to build and you're trying to build it from scratch, you might see there's a company that's already doing it, and you can utilize them instead of having to build it yourself. We do have hundreds of apps. These are just some of the companies that are on the Webex App Hub right now. And with that, let's see. So the Webex app here on the content, we have our space. I'm going to be in that space answering any questions that you may have over the next few weeks. You can access that space through the Webex app. You can join it through the Cisco Events app as well. Fill out your session surveys. I would love to get your feedback on this session. I know everybody loves T-shirts, and with Cisco Live, you have to submit at least 4 session reviews to receive your free T-shirt. And I also have some stickers to encourage you to submit your feedback. So I don't know if I can bribe you to do your feedback, but please come by. I've got some Webex for Developers stickers for you as well. There's also multiple things that you can do with continuing your education within the contact center and within Cisco Live itself. And the on-demand library will be starting next month. And with that, thank you so much. I appreciate you spending the lunch hour with me.
Okay. Super stuff. Hi, everyone. We okay to make a start, maybe? Yeah? Can you hear us? Okay. So, thanks for being here today. The topic we're talking about in terms of the managing and building and managing across domains tends to be a particularly hot topic, one that a lot of people in Cisco and with our customers, with our partners are very passionate about. We talk about it all the time, and I was particularly kind of keen to maybe have a little talk and try to clarify some of the things that aren't necessarily always very clear. It's not an easy one because it's a moving target that's moving all the time. So before we start, I have to tell you that in terms of timelines and exact dates and all of that, that tends to be a little bit tricky. But we'll try and address any questions you've got as much as we can, all right? My name is Magdy Louis. I work as part of the SP specialist team for a number of years. We sell enterprise networking solutions to service providers, and this year I also cover some of the UKI customers. We look after enterprise networking. My career, I've kind of alternated service provider, EN, overlap, and some security as well. I'm based in Ireland, and I also look after a community of engineers and architects in Cisco who sell enterprise networking, everything, and Catalyst, Meraki, IoT, we sell to our service providers. And like I said, I'm based in Ireland. In my downtime, I like to, like everybody else, try to de-stress. IT is a stressful job now. So do a little bit of video games sometimes. I like to play chess. I used to do that competitively when I was younger, but God knows it's kind of challenging to do that at this point. And I like playing squash. And the interesting thing about it is a two-way street. Think about the relationship between a service provider and their customer. It's a back and forth. A vendor and their customer. you and your internal customer. It's a two-way street. You're always taking the back and forth. And that's kind of the whole point of bringing this up, that squash and that two-way synergetic relationship. You're trying to build that between you and your customer. And to be able to build smoothly, you're building a branch, you're managing across different technologies, across different silos. Hands up if you think this is very easy. No? I didn't think so. So we try and just make it a teeny bit easier and clearer, or point you in the right direction, and hopefully this 30 minutes provides some value in that aspect, right? I should say, if you would be so kind to, point at that QR, log in there, what I'll do is I'll talk for 2 minutes on the next slide, and then there's a little poll running. So I'd like you, if you will, after seeing the next slide, put what's top of mind for you. What do you think your main concern is? And let's see how many of us are on the same page, and we can check that live, yeah? Super? Everybody's got it? Yep. Okay. So I'm sure you've seen this slide in other decks, but if you think about where we are, you start coming in from your home office, from enterprise, from factories, you've got cameras, you've got all sorts of clients, people from their phones, such as yourselves today, and you're all connecting, and maybe you're connecting through a network, an access side. There's a WAN network, there's an access, there's switching, there's wireless. You're going to Meraki dashboard, maybe there's Catalyst Center, ACI, ICE, third party, there's firewalls in the mix, there's hyperscalers in the mix over there, and there's all sorts of things. There's ticketing systems, so we often think about the technical constructs, but there are non-technical constructs. At work, do you have kind of help desk systems and ticketing systems like ServiceNow and Remedy and others? Anybody's using them? Seeing nods around, right? So that's part of the whole, approach. So as you go through that and you're looking at, okay, what do we do? How do we simplify? I want to simplify two things. Building a site, right? So you've got a new site, you've got an interconnect with campus DC, you're building some construct of the mix of this, and you want to simplify that build rather than being a complex cross-functional project that takes a long time. You want to make this more, what's the word, smoother, right? And then number two is, day two, I want to manage, I want to monitor, I want to troubleshoot, I want to fix, I want somebody to raise a ticket, I can go retrospectively, look at what's going on and do it. And yes, you go to a session on Catalyst Center, it promise you, and it quite rightly so, that it does that, and you can go back in time, and the Meraki dashboard does it brilliantly, and maybe the firewall dashboard. But the point is, you've got all of these, and then, okay, I want to be able to do that. So what we want to talk about is, we've done just that little introduction, my little spiel about the problem, but what I would like to talk to you about is two things. How do we build across domains, and how do we manage across domains, right? And we are in a bit of a, don't really like saying that, but we are actually on a bit of a journey to try and bring everything together. We were just talking about it internally this morning, and along this journey, there's a lot of steps. I went to one of our customers, I think it was a day or two ago, and they are using a mix of on-prem and cloud and third party, and they're like, I want to manage it all, and I'm kind of going nuts. I need it on one place, right? What can I do? And I was like, I don't want to be cheeky, but you can come to that session. Because that's exactly what we're talking about. That's exactly the poster child for the problem statement, right? So let me just switch and see what you guys think, if we're all on the same page. Did anybody put? Sorry, don't mean to lead you away. integrations, you're certainly in the right place. Who says tired of AI? I think we all are. You go to any conversation, but you know what? I love it because these are the 2 points I wanted to touch on. And you quite rightly, you're all bang on the money. Integrations, how do I make all my systems talk to each other, talk to a master single pane of glass and integrate all of that together? And 2, what's the other biggest complaint everybody says? Take our SD-WAN, for example. It's brilliant. It's super powerful. It does a lot. And people turn around and say, well, I don't know how to configure this, or I don't know how to configure that. Can you maybe help me? Where do I need services? What do I need to do to make it happen? And now, forgive me for what I'm going to say, but there's Gen AI components that will generate the constructs. There's predictive networks. There's all sorts of things that help you do that. But again, the capabilities, even though we try to simplify and we try to use the same magnetic UI and we try to use the same stuff, it's still going to be in different areas. So what we want to do in the next few minutes, I can promise you very, very quickly, I can promise you 2 things, right? I can promise you we'll move very, very quickly, so pay attention, hold on to your seat. And I can promise you the only fudge you'll get out of this session is fudge chocolate. But we'll keep it really real, okay? But we want to talk about the integrations and how we can simplify our life, make things easy by using that common pane of glass. And okay, I got this pointer, but I haven't figured out how to switch applications yet with it. So if we talk about building across domains, and that's where workflows is brilliant. And I have to tell you, I've been there a long time, and there's few products or few new things that got me excited like workflows. Because if you think about where we're starting, you've got multiple on-prem platforms, multiple cloud platforms, there's no little integration, or you're begging, different platforms for integrations. You've got a whole mesh of them, and simplicities were out of the window. Then we go maybe into a fewer platforms, so we're a little bit better. But are we there yet? No. But then with workflows, we're looking at one platform to be used on-prem, in the cloud. You can use whatever systems you want. We're not going to look for these systems to, can you do this for me because that's what I need. Let them be what they are, and workflows connects them all together. It uses all the adapters. So the adapters are like device drivers. They're languages. Think of it like you all speak different languages, right? Now, I'm not nowhere near smart enough to speak all these languages, but imagine if I was doing that and I could speak to each one in his language, and then I'm not asking you to understand, a colloquialism I would use, an Irish colloquialism I'd use, and I explain, there's no need. I'm talking to you in your native language, to each one of you. Wouldn't life be so simple? Like Star Trek, Universal Translator thingy? Any fans? So this is what Cisco Workflows does. Workflows is focusing on talking to each system in its own way. It's got adapters. And let's just get something very, very clear. There is a lot out of the box. But it's also allows you to build your own stuff. So it's got the power of both. If I told you, here's a system and you can build the connectors, then you'll say, oh, that's a big task. I don't have the time. But if I said, oh, here's a system and you've got the connectors built, somebody will turn around, I can guarantee you, and say, I want to build my own. So we give you both. Doesn't get any better, does it? So you've got the connectors to third party, you've got the cloud connectors, the on-premise connectors, you've got single sign-on, the same magnetic UI you see in Catalyst Center and Meraki on all our dashboards now. You see that, and you can cross-platform navigation. So that's the whole Cisco networking cloud. And cheekily enough, it says like everything everywhere integrated together. Right? sounds like a very marketing slide. Let's make it a bit real. So the message just I want to give today is that workflows simplifies and accelerates your automation need. How so? So you've got workflows, you've got this automation. It'll talk to on-prem platforms, cloud platforms, be it Cisco, but also third party. So you're not limited to only talking to Cisco platforms. Think of it like I want to do a branch. That branch has a firewall, has Cisco Meraki inside, has Cisco Catalyst SD-WAN, has a server that I need to build, has this, has that. And I can create a whole, like a project plan, translate that into a workflow, create that, and every time I need a new branch, I've got that little workflow done, and I can do it. How does it do that? That automation talks to, out of the box, we talk to Catalyst Center, we do Meraki, we do SD-WAN, we do ACI, we do ICE. We also talk to, we've got generic adapters like netconf, SSH, and HTTPS, APIs, so you can talk to. And out of the box, we also have integrations with common ticketing systems, address management, DDI, IPAM, everything. You can really connect it to everything. You can also connect it to hyperscalers. So you're building something in AWS and you want to connect to it, and it's part of your network. You can also automate that. And you can also automate cross-lateral integration. So for example, you've got a fabric on your campus and a fabric in the data center, and you're trying to get them to talk to each other. Now, everybody loves stories. So for the next few minutes, for the rest of the session, we'll just go through a story. And it's mostly true. The only parts are not true, aren't fake. They're just aggregated from different, rather than keeping you for hours, I've kind of aggregated experience from more than one thing into that story, but it's mostly one customer. So before we do that, the architecture is quite simple. You've got those adapters. They're like device drivers on a PC. They are just how I talk to translator for this, translator for that, generic translators, Ansible, Terraform, SSH, anything you can think of that's very common these days, it's there. Can we build additional ones? Yes, you can. These adapters go through, you connect to the devices, you've got tunneling, and then we've got that automation engine and a workflow. Has anybody seen the Scratch programming language they teach the kids? You know, it's like a drag and drop. You just drag and drop a workflow. They teach it to little kids. It's very, very simple. And that does that. You've got the workflow designer. You drag and drop. And we'll see a little video in a second. So let me tell you that customer A story. Okay? And you can see that I don't have a huge imagination. I call it customer A. And seriously, jokes aside, so nobody tries to guess that this stands for X or Y. It's just a customer. So that customer has a campus, a large campus, and they're using a fabric in that campus. Yeah? BGP EVPN fabric. So our SDA, but using open source EVPN. In the data center, they have a co-located data center in the same site. They have separate data centers, but there is a co-located data center in the same site. And these two share a common connection to the WAN. There are separate DC sites. The WAN, they do happen to be a service provider and they own some networks, but they also use other people's networks because it's a vast network. So we just used WAN 1, WAN 2, and there was actually 3 and 4. I didn't want a cluttered diagram. So there's MPLS, there's DSL, there's cellular, there's you name it, right? Carrier pigeon if they'll have them. And then you've got remote sites, you've got, branches with anywhere from 10, 20 to hundreds of users. You've got retail sites, like little retail shops, kiosks, 1, 2, 5 people. And you've got also partner sites where we don't always control what those partners and call centers and others have. So sometimes they have their own kit as well. And we have to create several cookie cutter solutions of these solutions, right? So Now, I want you to remember that diagram, if you will, because we'll keep referring to it. So the first thing they want to do is campus to DC integration. Right? They want to be able to connect the campus and DC. Remember that part of the picture? So they want to interconnect that. There's a fabric here, there's a fabric there, and we want the two fabrics talking to each other natively. Can you do it? Sure you can, but you want to do it easily. So integrations, simplicity. Those were your two biggest points, right? So we're automating that network-to-network interface. So the virtual networks are extended, the data center VRFs are exposed, and the firewall supports both macro segmentation, VRF to VRF, and micro segmentation with SGTs. All of that done very easily. Second use case, so the customer, rather than having all the swivels chair between different screens and controls, we've got a single one with workflows, which is part of the Cisco networking cloud vision. So if anybody's going to ask that question, that is part of CNC. The other use case is, remember those sites, the retail, the partner, the remote sites? They've got 5 or 6 profiles of sites, yeah? And we want to be able to bring them up. So we can create a workflow for each one of these. That workflow means whenever I have, profile 1 to profile 6, I need to get profile 3, I need a site tomorrow. Easy. Go in there, select the site, choose it, bring it up. Yeah? So that interconnection, that site has Meraki, Catalyst, a mix, no problem. On-prem, cloud, working together, integration, simplicity again. So, like I said earlier, you can use the out-of-the-box, or you can build your own. That's kind of the two possibilities you've got there, which gives you the flexibility of building a custom profile if you need to. You probably won't, but also the ease of having everything, the adapters ready. But it's not only the adapters that are ready. We have pre-made workflows. So if you want to build a site with Catalyst and Meraki, that workflow already exists. Yeah? And rather than you building it from scratch, it's there. You can use it as is. You could customize it. So that also helps make your life a lot easier, gives you an easy way. I always say, I'm lazy, I love easy solutions. You want to do it the hard way, that's not me. I'm the guy who always finds the laziest way to do something. And that is the laziest way to do it. So let's have a little demo. Take a look at what's going on. Now that video is available and you have access to it. I didn't use anything custom, so you can easily have that. So you go in, there's an automation hub, you get predefined workflows. This is like you going to find pre-built VMs, and you can take one and customize it rather than build one from scratch. So you got those workflows, you can find them. Here's the campus to DC we referred to. Here's the Meraki access and Catalyst SD-WAN example we use. There are others, there's loads of them. And we'll take these examples, right? So we take we want to build a site. You see the folder there? So it's folders, subfolders. It's very object-oriented. And within each folder, you can expand one of them. And you see, you can update them. So you can update, you can delete, you can reorder. And this is the bit I was saying about drag and drop. You could just, this is like, in Google Maps when you select the site, the hops, and you can move them around, or any other system. You could change the order. You can expand. You can go and edit this task. You can. One of the most common things you might want to change is checks. So your business, your organization requires certain checks. And you go, here's the flow, and I'm going to draw it. And within one of them, I want to add a check. Can I add a custom check? Yes. Can I do what I need? Yes. It's already there. It's 90% there. It's 100 if you will use it as is. It works. But if you want to customize it, you could just do very little work. And it works. You have integration between all the on-prem, Catalyst, Meraki, etc., and it doesn't get any simpler. You choose that, you finalize it. We've got the adapters, we've got the workflows, and we just say run workflow. And what would have taken weeks and months happens in minutes and seconds. And you can see here the progress. This is like you ordering fast food, going to a joint and ordering fast food, and you can see there it's being prepared, it's done, go to counter 2, collect it, in seconds it happens. Okay? That results in massive reduction in labor time, massive reduction in errors because you're not doing manual, you're not copying from here to there. Oh, I chose the wrong VN number, I didn't match the right one. I did this, I did that. No, it's automated, so that reduces error. Many years ago, I was responsible for, in a service provider in a previous life, and one of the things that burned out the people who did the implementation for us on the night was they made mistakes. They're humans, they're good people, and sometimes they made mistakes. And we were always looking for ways to automate things. So I saw things from your view as well. And what we would have always wanted was protect the people who deliver, simplify change management. We could do more, reduce our labor costs, improve our margins, everybody's happy, everybody wins, right? Simplification, integration. And it's free. Did I mention that earlier? Oh, I forgot. You don't need to pay anything. It's cloud service, hosted by Cisco, delivered in the cloud. It's totally free. If you've got the Catalyst Center, you've got the Meraki, you have the right to do that. All the adapters are supported. You've got the access to the full templates. Cisco single sign-on and identity access management integration works. It's integrated into the cross-platform navigator where you can go to Cisco Security Manager, you can go to the Meraki access dashboard and all the rest, and you can create your automation. There are premium tiers more related to getting access support and all the rest, like other vendors, but you can use it completely free. Isn't that fantastic? So, any questions on that part? Okay, well, there'll be another chance at the end to have a discussion if you want. So this, if you noticed, what is the one thing we didn't do here? We built sites, we built integrations, we brought things up very quickly, very nicely, very pretty, but we didn't manage day 2. That's a workflow. You click, done, end. Yes? But if I want to manage day 2, today Workflows doesn't do that. It might tomorrow. I'm not saying anything, I shouldn't, so don't get me in trouble. But for now, there's a separate tool that does that. And that is Catalyst Center Global Manager. What the Global Manager does is exactly that. It looks at Catalyst Center, SD-WAN, other systems. It doesn't have third party just yet, and it doesn't do Meraki just yet, but it's a moving target. It allows you to manage the systems, to monitor across. If you have multiple clusters, if you have a global network, if you have, sometimes you have scale considerations. You can't run one Catalyst Center, you need to run multiple, right? And you need to manage across all of these. So the same story, same concept, same everything we've discussed applies here. And we can do that. You can also monitor, you can also search. So let's say you've got 6 or 7 Catalyst Center clusters, and you're looking for that endpoint globally. How do you find it? You can do that from here. So CCGM runs as a virtual machine, and it's a very, has anybody seen the requirements for a single Catalyst Center? This takes 8 CPUs, 16 gigs of RAM. You could run 10 of these on my laptop. Yeah? It's very, very humble in its requirements, very easy, which means if you run it in your hyperscaler, it's not going to cost you a lot of money. Or if you run it on-prem, it doesn't cost a lot of money. It's able to manage Catalyst Center and SD-WAN in all its flavors. It's not fully GA at the moment, so it's still in field trials. But you get this dashboard. It connects, again, you've got the adapters, and you talk to Catalyst Center, you talk to SD-WAN. Sounds familiar? And you consolidate your sites, you consolidate your scale, you consolidate everything. You look in, you've got a single dashboard, you can see it there. You can see your routing, your access, your switching, your wireless, everything in one place. I'd like to see now the analysts who are blasting less for that before in the past, what they have to say about this. And you can see there, like you can go and zoom in, and if you want to look at something in particular, it cross-launch the right cluster, the right management system. And again, it's a single sign-on, remember? It's role-based access control, site-based, everything else applies, so all the controls apply, and you're able to do this across all the clusters. So very easy to manage. You get the consolidated metrics. You also see the endpoints. Endpoints are really important because who matters in the end? It's not the switches, it's not the routers, it's not the network. It's the people, the actual internal users who use that stuff. That's what matters. Does anybody disagree? So you can manage these, you can monitor, you can see. Suppose my colleague, he works with me and I want to find his PC and kind of annoy him for the heck of it. I can find it very easily here. Or he has a problem and I want to help him. And I can find him very easily. Solve his problem from here very easy. So just because it's got a massive scale doesn't mean you lose granularity or detail or any of that. You still have all of that. So, I promised you move very, very quickly. When we spoke about workflows, we spoke about CCGM. What I would recommend strongly to you is learn more about workflows. Look at your multi-domain design. What systems do you want to connect to? Not only the switching and the wireless, but the ticketing system, the help desk, the address management systems you want to use, the information systems, your databases, your inventory systems, all the rest of it. Work around that, and then build your targets. So you've got all the adapters in workflow. Adapters when you configure, so if you have 5 or maybe let's say 2 Catalyst centers, each one is a separate target. Each IP and credentials is a target. It's just the terminology. So build your targets, run a pilot, and in a few months or in a few days, you'd be an absolute biggest fan for this, and you'd be looking to implement it network-wide. And hang on, hey, it's in the cloud, it's free, it's SaaS, so what do you need to make it live? Nothing. Okay? So workflows simplifies and accelerates your automation. I should mention, or I'm required to mention, that there is, I know some might have questions now, but if you think of something, there's a Webex Teams room that's in the app, and you can come back with questions. We'll do everything we can to come back to you with as many details as we can, right? There is also the point about the session surveys. If you fill 4, you get a T-shirt. So everybody loves T-shirts. I got one CCIE T-shirt yesterday, and maybe I get one of these nice T-shirts. And there is also the World of Solutions. I'm sure you've been around and all of that. With that, before you go, one thing. Do you have anybody has any questions? Okay, there wasn't a lot of fudge in that session, if any, so please help yourself to a fudge chocolate before you go. And thank you for being there.
Testing. Welcome everyone. I'm just going to start a minute or two early. I'm going to use every second I can get, so there's a lot that I'd love to cover, and I want to take advantage of the time. So first off, thank you for taking the time to be here. There's so many other places you could be and so many other sessions, but you've chosen to be here. I want to acknowledge and respect and express my appreciation for that. My name's Tim Szigeti. I'm a longtime Cisco veteran, 27 years. I've worked with a lot of technologies, but the most exciting technology set is what I've been working on lately with the Cisco research team in quantum. And what we're working on and building right now is a quantum prototype switch that uses teleportation and entanglement swapping. Okay? Maybe that means something, maybe not. If not, then this session hopefully will provide a rudimentary literacy, a little bit of context of these concepts. But in order to understand what that's all about, and in order to understand, say, teleporting and entanglement swapping, we have to learn about quantum networking. In order to understand that, we also have to learn about quantum computing and the quantum gates. In order to understand that, we have to learn a little bit about quantum mechanics. I'm not going to expect you to, and I don't think you should set the expectation of being able to absorb it all in one go. It's a lot. It's a tremendous amount, but I do hope that you can take away at least 5 key points from our time together today. It's not working, but I'll do it the old-fashioned way. These are some 5 key points that I'd like you to hopefully take away. So what are some special properties of quantum bits? What makes quantum computers so fast? Can you transmit information faster than light? Part of this discussion is to help you to separate fact from fiction, because in the media, a lot of things get overhyped and over-exaggerated, and we want you to set the record straight. Also, will quantum networks replace classical current digital networks or not? Okay, and then finally, I hope I'll have time to cover very, very, very briefly what Cisco is doing. With all this context laid, it should make more sense, and then hopefully build some appreciation for the innovation and thought leadership that we're going on in that space. Okay, so let's start with quantum mechanics, also known as quantum physics. Physics is basically the study of matter, how it moves and behaves across space and time, how it interacts with energy and forces. And until 128 years ago, there was one set of rules for everything. What changed? Well, we discovered, until that point, we thought that the atom was the very smallest building block of the universe. There was nothing smaller than an atom, and then they saw that there was. And the more they observed inside atoms, they realized that these tiny, tiny particles, subatomic particles, did not follow the same set of rules. They had rules unto themselves, and these rules were often bizarre, sometimes even paradoxical. For instance, a primary rule and principle is that they have a duality. They behave both as a particle and as a wave simultaneously. You don't see this in the rest of the physical world, but it's a fundamental nature and aspect of these subatomic particles. We can use these subatomic particles to represent logical states, 1 or a 0, by looking at various attributes of them. We can use different modalities, that is, different types of particles to express these logical states. We can use electrons, which is most commonly used for compute, quantum compute. Or we can use photons, which is more common in networking. And we're going to see that, and I'm going to explain why. There's other things we can use too, trapped ions, neutrons, things like that. But let's say we're going to start with electrons. With electrons, let's just say this is an electron. We call an expression, the logical state, as a reflection of the electron's spin. Now, the first thing I want to say is the electrons don't actually physically spin. They're too small to do that. They're singularity. And so what we're really referring to by the term electron spin is a magnetic field that it emanates from the electron. If it goes out the top, the North Pole, and comes down to the south, we call that an upspin. If it comes down from the South Pole and up to the north, we call that a downspin. Okay? So, and then we're just going to say one of these represents 0, up represents 0. Think of that the default state even of the Earth's magnetic field. By default, for the last 780,000 years, the Earth's magnetic field have gone from north to south. But it does change. But with electrons, it's not just up or down, it's anything in between. And the cause of this electrical field is an innate property called angular momentum. And so it can be up, it could be down, it could be anything in between at any instant in time. So far, so good? Okay. Now, in order to start working with this, first we have to model that behavior. And the way it's modeled is mathematically initially. And so there's a quantum state formula that basically says that the quantum state of any of these particles at any instant in time is equivalent to the distance to state 0, that is a spin that represents logical state 0, spin up in this case, and then the distance to spin down. These corresponding distances are referred to as alpha for state 0. This is called ket 0, this notation, and ket 1, state 1, state 0 and state 1 respectively. So A is the distance to state 0, and more technically, it's called the amplitude, but basically it's distance. And then B is the same, beta for state 1. Okay, we can express this in many different notations. This is called ket notation, an abbreviation of bracket notation. We can also express this as a vector. A vector is basically distance and direction. So for instance, state 0 is equivalent to going a step unit of 1 in the distance of the x-axis, if we would graph this in 2 dimensions, and a distance of 0 in the y-axis. This is how we would look if we plotted it on 2 dimensions. It's exactly at state 0, fully 100% at state 0, and 0% at state 1. Conversely, the opposite state is expressed as a vector in this manner, and if we plot it, it looks like that on a 2D graph. Make sense so far? Okay, good. We're going to keep on moving. Now, if we simplify and express this formula, remember we said we could express it as ket, bracket notation, or as vectors, it would simplify to the vector alpha over beta. And what's interesting is that these 2 properties, if you square them, if you square the amplitudes, alpha and beta respectively, that represents the probability that it's going to resolve to one of the 2 states, one state or the other. For instance, let's say we have 0.8 amplitude in the 0 direction and 0.6 in the 1 direction. We square those amplitudes, and then that gives us a probability of how it will resolve. In this case, 64% probability will resolve to state 0, 36% to state 1. That's how these qubits work. It's all about probabilities of states, okay? Now, we're dealing not with a 2-dimensional graph in real life, but rather a 3-dimensional object. So how do we get from 2 dimensions to 3? Well, imagine then that you have a 2-dimensional graph on a plane, and I flatten that plane to a horizontal level, and imagine I could slide it right through the center of this tennis ball, okay? So you see where the x-axis goes? Laterally, from side to side. The y-axis would go dead center front to dead center back. And then now we have a 3rd axis, and that's a z-axis, from the very top down to the very bottom. And now this gives us a new dimension to play with. There we go. And so if we would rotate around the z-axis, this is called phase. Okay, so we've talked about amplitude, that's the respective distances from the x and y, and then the rotation around z is the phase. Good so far? Okay. Now, 3 unique properties I'd like to share about qubits. And it's not to say these are the only 3. These are just 3 that are most relevant to our discussion. The first is superposition. So you might sometimes read in media, oh, qubits, they represent 0 and 1 at the same time. And then it's like, it's a very paradoxical statement. How do you resolve that mentally? It makes no sense. It's a logical contradiction. And yet that's how it's often expressed because that's great media hype. But really what you want to think of it is it's a probability that's going to resolve to 0 and a probability it's going to resolve to 1, both of which are operated on at the same time. Let me illustrate. Think of a coin, okay? With a coin, we can say it has 2 states. It has heads and it has tails, right? So while it's in the air, though, what was its state? Was it heads or was it tails? While it was in the air, it had a probability of being one or the other. Maybe for a brief instance in time, it was perfectly 100% tails, perfectly 100% heads, but until I stop it and take the reading, I haven't determined the state. But once I do take the reading, it no longer has that possibility of being in two states. That collapses to a single state. So superposition is when it's in this variation, a probability between two states constantly in flux, but as soon as I take that reading, it collapses into a single state. Does that make sense? But I can operate on both values simultaneously. That's very important. We'll come back to that. The next property we want to talk about is entanglement. It is possible for these particles to enter a special and bizarre relationship. Einstein called this spooky action at a distance in his 1935 paper. Basically, they could be linked in such a way that any change in state in one will be immediately reflected in the other. Now, it may be an identical change, up, up, or it could be an opposite change if it's rotated. There's 4 possible Bell states. It could be something opposite, like one would go up, one would go down, and there's 2 other states. I can't get into that, but these are called the 4 Bell states. And it is possible to entangle multiple qubits together. It's not just a pair. You can do a lot more. Right now, the current record is 54 physical qubits entangled together. And similar to superposition, if I take a reading of that entanglement, the instant I do that, that entanglement collapses, and then the state of one, wherever one was, let's say that they're identically entangled in perfect sync, wherever this one was, the other counterpart, even if it's galaxies away, will instantaneously collapse to the same state. Bizarre behavior, hard to understand, but it's observable, it's predictable, it's controllable, and we can generate it. Okay, and then the last property that we're going to talk about very quickly is no cloning. It's impossible to copy information that's in a quantum state. And this intuitively should make sense because you cannot read it while it's in the quantum state. That's like trying to read what the value of the coin is in the air. You can't do it. Once you take the reading, you collapse the state, but it's no longer in the quantum state. Okay? Now, here's the intuitive proof, but for those of you, this is a Cisco University course. So here's the mathematical proof. I'm summarizing it on a single slide, but if you want to go into it in detail, there's a really good linked YouTube video, 10 minutes. It'll explain this proof. It's mathematically proven you cannot clone. That's an important property. All right, now we're moving on to quantum computing. I'm already 3 minutes behind. Okay, so before we get into quantum computing, it's important to level set how does digital computing work. So with digital computing, you need some electromechanical or electrical device to represent logical states of 1 or 0. We started with vacuum tubes, but we landed on transistors. It's far more scalable, cheaper. There's many advantages of transistors. If you have an iPhone 16 in your pocket, you have 18 billion transistors in your pocket. If you have a MacBook M4 Pro, you have 28 billion transistors. That's how we scale these circuits. These transistors are then organized into what we call logical gates. And then it's just an abstraction. It helps us then to express Boolean logic. And there's a set of universal logical gates. Basically, it says if you just take these 3 gates, you can express any Boolean logical expression at all in any circuit. And technically, all you really need is a NAND gate, but when you learn digital electronics, that's typically the 3 gates. It's just a little easier for humans to comprehend and work with, okay? But this idea of a universal gate set is important because I'm going to show you the universal gate set for quantum. So you can basically express any Boolean logic either with digital gates or with quantum gates. And then as you put these together, more and more complex circuits and more functionality is provided. Make sense? Okay. So quantum gates are unlike the digital gates. First of all, they always have the same number of inputs as outputs. You're never going to have two inputs like in an AND gate. Two inputs and one output. You're never going to see that. Always the same number, in and out. There's a set of single qubit gates that just do simple rotations. For instance, we said that logical 0 was spin up. If we then rotate around the x-axis, remember we said the x-axis was through the side? I rotate 180 degrees through the x-axis. Now what's my logical state? 1, right? It's not 0. It's the opposite. So this is a NOT gate. If I rotate through the y-axis, if I put it through the front or back, and I start at logical 0 and rotate half a turn, I also end up at not 0 or at 1. So it's also a not function. I just took a different direction to get there. And I can rotate around all three axes, and I don't have to do a full, not a full, I should say, I don't even have to do a half rotation, 180 degrees. I can do quarter rotations and other things like that. And then I'm going to come back to the H gate in just a minute. So there's a set of unitary rotation gates. These are part of the quantum gate set. As we talked about, this provides a not function. If I start at 0, I'm going to end up at 1. There's the math behind it. And this is also an interesting point, is that all these quantum gates, they basically execute matrix multiplication, linear algebra. This really makes them very well suited to AI apps, because that's what AI does, you know, all the latest Gen AI. And that's why GPUs are so valuable to power AI. So quantum gates do that natively. This gate I want to talk about. This is a little bit different and very important. You're going to see this at the start of almost every quantum circuit. The H gate says I'm going to do a or quarter rotation around an imaginary axis that's halfway between the x-axis and the z-axis. And so from the side, I do a half rotation. So if I start at the North Pole, I'm going to end up at the equator. If I start at the South Pole, I end up at the equator. And that's the very point of this gate. It's an initialization gate. I want to make sure that I'm going to get to a 50-50% probability to initialize my circuit. Remember, probability is the square of the respective amplitudes. If I square 1 over root 2, I get exactly 50-50% probability. And that's where I want to start from. Okay? One last gate I'm going to cover, and that's the C-NOT gate, the controlled NOT gate. Now, to understand this gate, I'm going to use an analogy from digital gates, and that's the exclusive OR gate. For those of you that remember these gates, basically it says the output will be 1 if the inputs are different. If I have 2 zeros input, I get 0 output. If I get 2 1s input, I get 0 output. But if they differ, if these two are different, I will get 1. Yes? Okay, now remember I said with quantum gates, if you have 2 inputs, you have to have 2 outputs. That's just the nature of these gates. So let's say I'm just going to tap into the value of A and carry that forward, untouched, and compare that to the output. Fair? So I'm basically just copying column A, and I'm repeating it over here, okay? There's no real magic. Now, take a look at the output when A is 0, and compare the output to B. What do you observe? Same, good. When A is 0, the output is the same as B, the input. Now, when A is 1, compare the output to input B. What? Opposite, or not, right? Whenever A is 1, the output is not B. Yes? So A is controlling a not function for B. Does that make sense? That's the essence of this gate. Now, with this gate, plus the unitary gates that I've already showed you that do rotation, we have a universal gate set. So we can express any Boolean expression in quantum circuits that you do in digital circuits, which means you could program a quantum computer to do anything that a regular computer does, but it doesn't necessarily mean it will be better at it. To really see a difference, you have to leverage the unique capabilities, and then you can get either a quadratic advantage, which is x squared advantage, or you could get an exponential advantage. I don't have time to get into those two, but in my other session, BRK ETI 1401, I do get into both and explain that in more detail. You put all these together, this is the kind of circuits you end up with, quantum logic circuits, and then they're very powerful. And at the end, incidentally, there's a classical operation. You do the reading using classical digital circuits, and so really any quantum computer is not pure quantum. It's really a hybrid. And you're going to see that theme again in networking. Okay, now what really makes them powerful are two key features. And the first is quantum parallelism. Because each quantum bit can operate on both values 0 and 1 simultaneously, it's the same as if it's representing both of these simultaneously and operating both of them. So for every quantum bit, you're doing twice the work for every single bit. I add another bit, now I'm doing 4 times the work. It's an exponential increase. I add another quantum bit, now I'm doing 8 times the work, and so on. It's an exponential increase in capabilities for every qubit that I'm adding. The other key benefit is interference manipulation. So this is interference manipulation can take 2 forms. You can either be constructive. 2 waves, you line them up perfectly in sync, and then you get 1 super wave. And then if you increase the amplitude, remember you increase the probabilities. And so you're manipulating the probabilities of a given outcome. Conversely, you can be a destructive interference. This is how your AirPods work, right? Noise cancellation. They take ambient noise, reverse the phase, and then when you put those two together, they kind of dampen each other out. So you reduce the probability of, for instance, the wrong answers, and then at the same time as you program your circuits, you want to increase the probability of the right answers. That's what you want to optimize. And so you get to the answers much, much faster. And then so instead of classical approach to problem solving where you go through every iteration exhaustively, with quantum, you do, for instance, a few passes, and then you'll have a higher probability of what the right answer is. And you're going to get to the answer sooner using these type of models. So it's a little bit different overall approach. Then how much faster is a quantum computer? I'm going to go back a few years just for the sake of an analogy. So in 2021, the world's largest quantum computer, 127 qubits by IBM. So let's imagine, and it was 158 million times faster. How much faster is that in real life? So consider, my wife's Greek, so I asked her, I go, okay, give me an example of something that happened 2,500 years ago. She's like, well, we were building the Parthenon. It's like, that's the biggest thing that was happening at the time. I'm like, okay, great. So imagine you kick off a computer program, a job, at the same time the Greeks, wonderful people, were building the Parthenon, and then you leave that running. Rome really hadn't come on the scene. Rome comes on the scene, lasts for 1,000 years, goes off the scene, Dark Ages, Renaissance, Modern Era, etc. Quantum computer could do the same job in 1 minute flat. That's the kind of speed up. 2 months ago, Google announced that their latest Willow quantum computer could execute in 5 minutes a job that would take 10 septillion years. I find that you can't even comprehend that. It's basically, the universe is about, let's say, 14 billion years old. This is 10 quadrillion times that amount. You can't even imagine then how much faster, but every time you add a qubit, you get that exponential increase. What do these machines look like? Here's some examples, depending on whether it's marketing or an actual use in a lab. And then here you see it stripped of its cover. And basically, this is a quantum element. The rest is just all circuitry and controls and shielding. They're sensitive to temperature, noise, vibration, EMI, et cetera, et cetera, et cetera. Okay, Now with that, let's switch gears to quantum networking. Okay, I knew this was too much. Okay, so now instead of using electrons, we're going to use photons. Why? Because those, we just said, are incredibly sensitive to many factors, EMI, even temperature. They're kept at minus 273 degrees Celsius. You cannot keep your entire network, including all the media, at 273 degrees Celsius. It's not practical. Whereas photons are not temperature sensitive, and therefore you can use existing media like fiber optics. But with photons, we're not looking at electron spin, we're looking at polarization. Polarization could be expressed like if you drop water in a pond, then the waves, the plane which way the waves propagate is horizontally. They stretch out horizontally, that's horizontal polarization. Light obviously isn't bound by gravity, and so it can be polarized in any direction. I have lenses here that are polarizing vertically. If I turn one of the lenses to the side, less and less light will get through until none gets through, because this light is isolating on a plane, vertically, horizontally, anything in between. Okay, so then how do we entangle these photons? Well, we got a really fancy name for this process, spontaneous parametric down conversion, but really what it amounts to is you just take a really powerful laser pump and you shoot it through a crystal. This is what it looks like in a lab. It's a nonlinear material, and then it takes one high-powered photon and then splits it apart into two lower-powered photons that enter in this unique entangled relationship. Okay? Now, when we communicate classically in optical, we send a bunch of photons all at once. And then along the way, photons often get dropped. I don't know if you noticed that, but it's subtly in the animation. Some of the photons are missing. But if you're trying to send a single photon and then that goes missing, now this is a real problem. And so transporting isn't the best option, particularly because the decay or attenuation increases exponentially according to distance. You might say, well, why don't we just amplify that as we go? We can't, because of no cloning theorem. You can't read and then replicate and amplify. You can't touch it that way. So you got to do something else, something really cool, teleportation. All right, so here's how it works. You start with a qubit from Alice to Bob, and then before we do anything with that qubit, we're going to entangle another pair of qubits. We don't care what's, their state at all. They're just a media for us right now. So we're going to entangle them, and we're going to send one of them over to Bob. We're going to call these A and B. Okay? We're going to send one all the way over to Bob. Now we're going to perform another entanglement that includes Alice's original qubit state. So now these three qubits have the state of Q plus the state of A and B. Think of it, they have the signal, Q, and they got a little noise that was whatever their state was originally, because those states have merged, like two waves colliding. Okay, no problem. Then what we're going to do next is we're going to do a Bell state measurement on A, and that's going to break the entanglement, but it will tell us how they were entangled. Were they synchronized? Were they opposite on the x-axis, on the y-axis, or, I'm sorry, the z-axis, or both? It'll give us which of those four states, those Bell states, they entered into. Then we send that information over, and then at the far end, now Bob knows what to do to get rid of the noise, if you will, to undo the effects of that entanglement that established the teleportation channel. In this case, we're just going to rotate via x. We still don't know the value of this. It's kept the value preserved. We haven't read it. We've totally preserved superposition and every other property, but now we're going to correct that, and then now we have that qubit in its original form, and it's been teleported over to Bob. But we needed to send a photon over to establish a channel, and we had to send this reading over digital channels in order to decode it, if you will. Now, we can extend this process link by link by link, and then complementing it with entanglement swapping across intermediate devices. Remember I said we're working on a switch that does teleportation with entanglement swapping? This is the basic operation that we're doing. And then basically here's how it would work across larger distances. We establish these channels, and then we're able to do end-to-end entanglement. And then if need be, we reroute, reestablish, and go on and on and on. Okay. Very quickly, I know I'm out of time. I'll do this as quickly as possible. 3-step approach. There's so many engineering problems to solve in this space. We're playing to our strengths. We know networking. Others are running after compute. We're focusing on the networking challenges in order to connect these distributed quantum computers together. There's many challenges. So how do we go about it? 3 steps. Research, mathematical modeling. It always starts there. Then we have simulation, emulation, and then ultimately testing on lab beds and developing hardware, software. So we're publishing like 10 papers or more on average a year in order to set all the principles and set the direction, maximize the use of existing infrastructure, or whatever the case may be. We're also looking at using photons for compute. When we discussed it, we used electrons in our discussion earlier. We have quantum network simulators and emulators so that we can design these networks, and then API programmable test beds so that we can actually get them onto optical tables and start finalizing the best set of hardware. We've already produced some innovative hardware such as quantum repeaters, quantum random number generators, etc. But yes, this is what we're currently building. The quantum-enabled switch, and then we'll build a local network, and then a fabric, data center, and then interconnections with regular networks. Remember, all of this will be hybrid networking. Okay, so summary. Remember I said I'm hoping you can just walk away with at least 5 things. I've dumped a lot on you. I appreciate you sticking around and paying such close attention. But let's get these answers. Let's do the summary together, and feel free to shout them out. What are some special properties of qubits? I'm looking for 3 things. Pardon? Non-deterministic, okay, but in our discussion, we talked specifically about 3 aspects of qubits. Entanglement was one, okay? Any remember the other ones? Superposition, good. Superposition, entanglement, and also no cloning. That's important for both compute as well as, that's why we couldn't amplify signals in transporting scenarios with the network. What makes a quantum computer so fast? 2 things. Quantum parallelism, yeah, that exponential increase. Every time you add a qubit, you're double the speed and capacity compared to its digital counterpart. Does anyone remember the other one? It was the interference manipulation. If you align these in an intelligent way, then the amplitude, or correspondingly the probability of the correct answers, will magnify, and the probability of the incorrect answers will get smaller. And so this will get you to your final answer that much faster. Can you transmit information faster than light? And I want you to focus on the word information. No, that's great. So that's a key point. In the media, you're almost always, not almost always, but frequently I've read in the media, you can quantum promises faster than light transformation of information. That's impossible. Okay, nothing can transfer faster, no information can transfer faster than light. Yes, the bits, the entanglement can reflect each other, but that's not information, because you don't know, did I get the bit, or did I get the opposite of the bit, or the backwards of the bit, or the backwards opposite? That's not information yet, that's still just random noise. Until I make that measurement, and I send that over, and then I remove the signal from the noise, now I have information. Okay. Finally, will quantum networks replace classical networks based on what we just saw? Yes or no? Who says yes? Who says no? All right, good, good. So no, unfortunately for the yes people, no is the answer, because we have to send a photon, physically transport a photon over to establish the media channel. We have to send 2 bits of information representing the Bell states that were measured over classical channels. There is a mathematical dependency on classical digital networks for all quantum communication, and that will always remain that way. Okay, thanks so much again. I hope you took a few things away from this. I really appreciate your time. Apologies for going a little bit over. Enjoy the rest of the show.
I can't hear. Oh, there we go. Welcome. Welcome, everybody. We're going to get started right on time. So, my name is John Kuchta. It's nice to meet you. We're going to talk about design principles that we've learned at Meraki in development of our APIs, how they actually affect the APIs that we build, and if you're building software, principles that you can integrate into your own. First, a couple things about me. I'm a product architect with Meraki. Actually, I should update that because I got promoted last year, so I'm actually now senior product architect. Very proud of that. I work on Cisco's API strategy for network platform, so that's Catalyst Center and Meraki. My specialization is Meraki. And I've been doing development consulting and IT management consulting for a long time. Used to work for a Cisco Gold partner, where I was managing quite a bit of engineering labor, network engineering labor, and projects, which I am not a huge fan of project management personally. I know there's experts that do it. My wife, in fact, actually has the, what is it? CAPM? Does that sound right? Anyone a project manager here? She's got an associate certification for project management. But a lot of respect to people who do that. I like geeking out more about networks. Actually, Fluke booth, by the way, was like one of my favorite places to go. So that's just where I am from an infrastructure standpoint, my background. Please hop on the Webex app if you have any questions around what I'm talking about today. You want to have a more casual conversation, this is a great place to do it. If any of you are going to ask questions, I am hopefully going to be available shortly right after this to talk to you one-on-one. But also feel free to ask here because then everyone can see our conversation and benefit from those answers and perspectives. So we're going to talk about the principles. We're going to dive into each one of them. We're going to talk about some of these new operations as we go through them and hopefully have some time for Q&A. So what do we mean when we say scale considerations, right? So what does it really mean for something to be scalable? That is the question. So first of all, and this is really important, whether you're a product manager or whether you're just trying to get something done, what is the business outcome that you are after? What is your business trying to achieve? That is much more important than the technology. That is much more important than the implementation details, because if you don't know what you're trying to solve for, everything else can get much more complicated. So the first question that we have when we're going to build an API operation is, does it accelerate business outcomes? Right? That also helps us prioritize the API operations that we could build. And is it relevant to the ecosystem partner? We have actually representatives in the audience from some of our ecosystem partners here. Welcome. Our enterprise customers and to MSPs, right? Whether they're actually like classic service providers or just smaller managed services providers, does it actually help them get things done? That is a really important question. The next is, does it perform well for really large environments? It's not very difficult to solve for something that's got like 5 switches and like 10 access points, right? Like that's not very impressive. So we're wondering, will it actually work well, performantly? Will it be fast when you're actually working in a very large environment? And then separately, will it feel efficient? We're going to talk a little bit more about what that means in a moment, but will it feel efficient when you're actually using the features? And finally, is it intuitive to use the operation, right? There's like a Venn diagram of people who are interacting with many networking platform APIs. And the diagram is one circle over here, which is developers who are not network engineers. And then there's network engineers who are not developers. And there's a small overlap. That overlap is very, very small. Welcome if you're in there. Welcome if you're on either side of the circle. But it is important that the operations that we're shipping are intuitive. In other words, as a human who is not a developer or necessarily a network expert, can you look at the docs and say, oh, I know what this does? Right? That's really important. And so we'll talk about what that means and how you can actually get that done and how it actually manifests in Meraki APIs. And finally, can you actually use it without a lot of prior context on Meraki or just Cisco or vendors in particular, right? This is really, really helpful for building an API that is well adopted. So the first principle is called naming and organization, right? So when you're building an API, you want to name and organize everything that's being offered in that API. I'm focusing on REST API today. If you're not familiar with what that is, it's an inbound API. We use JSON structures to represent data. And so when you're actually going to build the JSON structure for the data, the principles that go into that are your names for the keys in that data self-documenting? Are they clear? Are they explicit? In other words, if you give something a name in your JSON blob, is it get confused with anything else? Or is it really clear what it is, right? That's an important principle, and it seems simple, but it actually can get devilishly difficult. Is it unambiguous, right? You don't want it to be confused with anything else. And is it self-documenting in the sense that you don't necessarily have to go and read the doc string, the description of it, to say, oh, okay, I know what this does. Sometimes it's kind of unavoidable, right? But a great name is self-documenting because it's named exactly what it is, right? That's a difficult thing to do in practice, but it's very valuable. Also, when you're building those JSON structures, and we'll get to the examples in a moment, are you grouping them to illustrate the relationships, right? There's a number of different examples. We'll show you one here. But if we think about, say, wireless networking settings, is anyone a wireless engineer configuring SSIDs in the audience? Nobody. Okay, is anyone a switching engineer? Okay, a few people, all right. So when you're doing the switch port configurations, there's lots of different sub-features of those ports that you can do, right? And there's like trunking settings, and there's VLANs, et cetera. And organizing in the JSON the ones that are kind of dependent on each other really helps people understand what they are looking at and whether they can like ignore this part of the blob because maybe they're not using that setting. Again, we're going to get to the examples in a minute. Also, avoid abbreviations. Avoid the shorthand that like your particular company might be used to using if this is not like really well understood industry standards, because that shorthand seems simple at the time. You feel like you're maybe iterating a little bit faster in your personal development practice, but over time that documentation just kind of spirals, and honestly, like you probably could have avoided it from the start. So let's going to start with this operation. This is actually a pretty new operation called get organization, switch ports usage history by device by interval. Now, has anyone here worked with switch telemetry? Not necessarily Meraki telemetry, but telemetry about switches. Yes, yes. So what do you think this does? This is not a test I'm about to tell you, right? Well, it's going to look at the usage history of your switch ports. It's going to give you a history of it, and it's going to give it for all the switches in your organization, and it's going to aggregate the telemetry by an interval of time, right? So what does it look like? It looks like this on the right side. This is an actual response. This is an example response, but this is what it looks like. And you'll see that we have some principles here, right? The first is that it's grouped in a way that helps you understand what's what. It's not nothing's flat here, right? So if there's certain pieces of this that you're interested in and others that you're not, you can immediately just ignore it from a structural perspective, right? But you have things like the name and the serial and the MAC of the switch. That's stuff that's really helpful context, but you know exactly what those things are. Like that's not really a complex thing. Network has its own group. Now see, that's a technically speaking database language. That's a foreign key and a record for a foreign resource, right? So that's grouped separately because that has nothing to do with the rest of the telemetry, right? And then you've got your model and then ports. Now the ports array here is giving you an array of all of the ports on the switch. And for each port you have a port ID. Well, I wonder what that means. Probably you understand. And under intervals, that's all the intervals of the data, right? So if you're thinking like if you were thinking of like open telemetry, this would be data points under a metric, right? So start TS, NTS, start timestamp, end timestamp, right? So you understand, okay, that's the start and end of the interval. Now data usage total is this number, right? 4867. The units are documented in the doc strings just to keep the response clean. Open telemetry would give you the unit in there, right? But we tell you what it is. All of these, by the way, are the same unit when they can be. Bandwidth is separate because bandwidth is data over time, right? So it's an average of what the actual throughput is. Data usage is like if you're calculating like a data cap, right, on a cellular plan. And then energy is also shown here, and that's in joules, if I'm not mistaken. But you can see that we've grouped the related attributes, right? And we've used a consistent structure here. Total upstream, downstream. Total upstream, downstream is repeated here because that's what, like, it doesn't need to be different, and we're not flattening that structure. So if you're only interested in bandwidth, you focus right here. If you're only interested in data, you focus right here. If you're only interested in energy, you focus right here. You can ignore the rest. You don't have to parse through everything at the top level. So we've also avoided any unnecessary abbreviations. TS is pretty fundamentally understood as a timestamp. But yeah, so that's just an example. The next principle, prioritizing signal. I mentioned open telemetry. Open telemetry is very, very cool. Telemetry in general is very cool. Most data points are noise. Feel free to at me later if you disagree, but most data points are noise. This is a really important principle. you can prioritize signal in the offerings that you have, and that's what we try to do, to make outcomes more efficient. But how do you actually do that? You need to be able to distinguish noise from signal. And again, you can't do that without understanding the business case, right? So what is the use case for the data? Because noise in some cases is actually signal in others, right? So the business use case defines what the signal is. The signal is going to drive someone getting it done more efficiently, right? More than like having to look through like an entire syslog, all the events. Oh my God, I'm going numb because it's kernel messages, right? But that said, you can help people wade through that data set by equipping them with filters. So if you tell us, hey, I only want maybe events for wireless devices. I don't care about all the other stuff in the stack. Or I only care about a specific time span. Or I only care about X, Y, and Z. If you can build those into your API like we do, you can filter your query so that we only give you the information that matters to you. And this is so much more efficient than having to get the whole data set and to do the filtering client side. Oh, sorry. Irrelevant data is just noise, so leave it out when you can. So an example of this, many of you who have used Meraki Dashboard API are familiar with get organization devices statuses. Yes, this operation is deprecated. And no, I don't mean that it's dead. It still does work. This is our recommendation. Instead, we actually have a little bit more context around this. But this is basically reimagining the statuses operation. If you were to have a point in time and knew what all your devices were doing at, say, midnight of this morning, 5 minutes later, you asked again, what's all the statuses of all my devices, right? Well, hopefully, you're getting actually all the same data you got at midnight, right? Hopefully, which is kind of awkward to say because all of that was just seems like a waste of time, right? What if we could just tell you what changed in that time span? And so imagine a really large organization that has like tens of thousands of devices. Well, getting all of the device statuses on a regular interval is like really kind of exhausting. With something like this, you can give us a time span and say, what changed during this time span? I got a ticket. Wednesday morning, people were complaining the Wi-Fi was down. Did anything go down right around that time? How about in the preceding 24 hours? With an operation like this, you can actually do that. And you can see that we're organizing it in such a way that it's pretty easy to understand, right? Old status was online and the new one is offline. This thing went offline at that timestamp. And it was an MR34, right? Another example, get organization devices boots history, right? So devices don't just reboot, they also boot. So any reboot is a type of boot. That's why it's called boots. But we have, pretty straightforwardly, a serial, the network and its ID, and when it booted. Now, why are we not doing uptime? Well, because you just take the current timestamp and subtract that timestamp and you have uptime. But in an API, it'd be super inefficient if every time you called, you got a different value for uptime, right? So we're keeping it simple. We're giving you time series data from a time series database. This is when it did the thing. So maybe you're wondering, okay, maybe it went offline, maybe it didn't, but it's back online now. Did it actually go down? Did it reboot at that time? And you'll be able to use this operation to do it. This is an early access. Another operation. This one, criminally underused, by the way. Using this, if you're in any role with Meraki Dashboard where you need to manage configurations and configuration drift, some iterate through every single API operation, get, and they do that on an interval, and they back that up. Now, that's totally fine. You can do that. Or you can check what changed in an interval. So once you have that initial state, what changed in the last, hour? Nothing? Great. Empty response. So much more efficient than going through and iterating on all those attributes. And for the most part, the config is revealed in old value, new value. A couple edge cases where it's not, but in those cases, at least you know, okay, I should actually go and pull those other pieces of config. This is another new one. Organization devices, system memory usage history by interval. What do you think it is? Well, yes, it is the device's system memory usage history aggregated to an interval of time. So we're following the same principles here, right? Serial number model, well, the model, this is not a true model number. This is an example response. The name and the MAC, blah, 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 blah. Provisioned. That is the amount of memory that is the hardware provisioned on the device. We use provision very carefully because there might be a change in that over time, depending on like firmware and that type of thing. Used, median score is 100. So for that entire time span, you gave this a time span. You said, show me the last 24 hours. Maybe the interval is 1 hour, right? That's the difference between interval and time span, by the way. You're looking at this and, okay, this is saying that the median used was 100 out of 300, right? And free was 150 out of 300. median for the whole time span. But then we break it down, and we actually go into the intervals, and we say, okay, breaking it down hour by hour, in this case, it's actually, these timestamps are actually exactly the same. Am I seeing that right? Yeah, so these are the same. So this is just a rendering error, really. We're showing you, okay, this is how much memory was used, minimum, maximum, medium, and then the percentages, so that you can understand what's going on for all the devices, not just switches, devices, cameras, anything in your organization, very, very quickly. And the next and final principle that we're going to cover today is that when you're building API operations, especially REST API operations in particular, like we are, it's a good reminder to start with CRUD. Does anyone know what CRUD is in the context of REST APIs? A few people? Yeah, so I'll explain it, don't worry. The concept is basically keep it simple, get crazy if you need to, but CRUD stands for create, read, update, delete. Everything that you're building an API for is in some way represented as a resource, right? In some cases, those resources are serialized, which means they have a unique ID, right? Sometimes it's a randomly assigned, it's like a UUID or randomly assigned integer, that type of thing. But in the case of organization networks in Meraki dashboard is a perfect example. You're going to create a network by using a create operation, that's a post. And you're going to look at the index of all of those via get networks. And if you want to update a single one, you're going to use a put. And if you want to delete one, you're going to use a delete. This is a basic concept, right? But if there's anything that you can represent using this is a form of UX, right? Not graphic UX, but API UX. If you're building an API and you can use CRUD to get it done, and it makes sense, and it makes sense to you, makes sense to your engineers, use this. Don't stray from this. This is like almost fundamentally understood amongst like REST API developers. And it will be so much nicer, especially when you start looking at like the database transactions that are happening under the scenes, right? Delete, well, that's a pretty clear like drop SQL command, right? Put, well, that's an update, right? This maps very cleanly. Now I'm going to talk about relating resources and an example, something that we've learned recently. You've got two resources. You want to link them in some way. Imagine RF profile, you want to assign it to a device, right? Or a config profile for maybe alerts, and you want to assign it to some number of networks. You've got two different resources, each with their own primary keys. You want to link them in some way. Well, let's imagine it as CRUD, and if you can, you really should. So think about combining those two resources with a single resource that is a simple row in its own table called assignments or bonds or links or whatever terminology makes sense for you, where the columns are things like the assignment ID, which is primary key for just the assignment, and then the foreign key for the one resource and the foreign key for the next resource. Now, it could be 3 or 4 or 6 resources, right? However many you need. But if you build the assignments and use this as the foundation for how you're relating resources, you can use standard CRUD to link things. Instead of going through all of these different operations and saying, okay, well, I need to like put this one, and then I need to like do a functional resource on that other one. And so, for example, you can say create an assignment. So whatever the resources are, you have an assignments extension to that, create a new assignment. It's just going to create a new row in this table. You're like, I've got this resource ID 1, resource ID 2, want to create it, it's going to create the row, it's going to generate the ID, boom. That is a super easy API operation to build and maintain, and it's super, super fast. It's also pretty easy to understand, right? And so if you want to kill that association, delete. You want to find out what all the associations are, it's an index on that table, right? This is something that even sophisticated engineers miss sometimes. But again, it's just a form of keeping it simple and using CRUD. So let's talk about a new feature for the MX device called local DNS profiles. Local DNS profiles is basically a way for you to put into the MX A records that it will then serve as a DNS server, right? I'm not going to talk too much about the configuration of the A records. That's a slightly separate thing. But if you're going to look at what all the assignments are to different networks, the assignment is linking a profile that you've created to a network, right? So I showed you that table before. We've got an assignment ID that's the primary key for the assignment. We got a network ID that's a foreign key for the network. And we have a profile ID, foreign key for the profile. And so when I wanted to link this profile to this network, I did a post to the assignments operation, and it created this. The meta stuff we can talk about offline. I'll save that as a separate thing. But this just helps with pagination and understanding where you are with the data set in case it's really, really big, right? But standard CRUD is great. Like I said, start with it. If you have a case to do things in bulk and CRUD on a per resource basis doesn't seem like it's going to be efficient enough, or you have a UX that wants to like delete 10 things at a time, 100 things at a time. That's where things like bulk CRUD can come in. Now, this is a little confusing because technically speaking, bulk CRUD is what we call a functional resource. It's not technically CRUD. It's not creating a resource exactly. It's accepting an action. You're telling us, I would like you to create all of these things. And so a bulk create operation is going to be a post action. Bulk update is also going to be a post action. Bulk delete is also going to be, sorry, that says delete, that's wrong, is going to be a post action to delete. And you're going to tell us, this is all the stuff I want to create. Bulk read, we already do, right? Index, get organization devices, for example, it's already a bulk read. It gives you all the stuff in that index. So if you wanted to create these assignments and you wanted to create them in bulk, you don't have to give them to us one by one. In this, you're going to send us a format like this. You're going to say, I want you to link that to this, I want you to link that to this, and you can go down the list, right? All in one API operation. If you've used action batches before, it's kind of a similar concept, except you don't have to worry about action batches. It's just doing it as a single atomic operation, and it can be very efficient. Similar for delete. All we're looking at here is the primary keys on the assignments, and you're just saying, I would like to delete all of those assignments. In other words, unlink those profiles from all those networks. And this gets it done as a bulk operation. So when you're doing these things at scale, it's really, really helpful to start with the CRUD and then augment it with these functional resources if you have a use case to do it. Slightly more complicated to implement, but the ability to do this is actually easier than writing with like Postman, for example, right? You can put this into a single Postman query. If you were going to iterate with Python or with Postman, you'd have to write a separate script that like iterated over all the different assignment IDs and then send that however many times, right? And it also saves you API calls, as an example. So let's recap. Naming an organization, it makes your operations, it makes your features easier to, what I say, doc and grok, right? Easier to document for your engineers and for your product managers to actually write out what it is, what it does, right? That can actually be a non-trivial amount of effort, especially if things were named really poorly or organized really poorly, right? So you're going to pay the price in some way, might as well just name it and organize it well from the get-go. So it makes it easy to doc and grok. Next, prioritize the signal over the volume of data. We talked about devices, statuses, and availabilities. Probably the volume of calls around like, oh, is it up now, is it up now, is it up now? It's a lot less valuable than just knowing, oh, nothing changed over the past 24 hours. So if I have a case that came in this morning and nothing has changed in device statuses over the last 24 hours for my entire organization, pretty unlikely that something went down to explain this ticket that's coming across my help desk, right? So that's what we're talking about, prioritizing signal. And again, understand the use case for the data, because sometimes the use case is knowing I need to know everything that is up right now, right? In which case it's no longer noise, now it's signal, right? So, and start with CRUD. If you're going to build API operations, whether you're building it for your own services internally, start with CRUD. If you can imagine what you are managing on the back end as those like separate tables, one table for each resource, and then an assignments table as an example, start with CRUD, because CRUD maps really easily to those SQL commands that you're probably running on the back end, right? And that's really, really nice, because then your API can be fast, easy to document, easy to understand. But you can augment it, right? You can go beyond that. It's not meant to be limiting. If you have bulk use cases, you can build bulk operations that are functional resources technically, but can speed things up beyond what standard CRUD normally does. So, thank you very much for coming today. Hope to have some Q&A. Do we have time? We do have some time, so we'll open that up. Please fill out the session surveys. This is so helpful for us, right? We love the feedback. If you could hear me, great, thank you. If you couldn't, but you still found the content valuable, please send those 5s. It's super, super helpful. I'll be around here for extra questions, and I'll call on people if anyone's bold enough to ask. But this is super helpful. It also helps the organizers understand who they'd like to see come back and how to tailor the content better so that it's more compelling. So thank you so much for this. Any questions from the audience? Well, thank you. Thank you for coming. I'll be up here in case anyone has a couple questions. I'll be up here until at least the end of the session. Thank you so much for your time. Appreciate it. Please don't forget the session surveys.
Yep, we are live. Okay. We're just about to hit the bottom of the hour, so I think we will get started. So thanks everybody for joining today. We're going to spend roughly the next 30 minutes together, and I'm going to give you an overview of Cisco Secure Access with emphasis on some of the recent innovations that we have added into the solution and are announcing this week. Okay, so first of all, I'll give a quick rundown on what Cisco Secure Access is, and then I'll talk about the innovations, and hopefully there'll be a few minutes left at the end for QA, and then, you know, if we need to discuss any more, we can as well. So what I want to do is make this a bit more interactive and a bit more fun. So you might have seen this already before in some of the other sessions you've been to. So where have you joined us from today? This should be an active poll. Okay, whoa, Scotland. Okay, let the answers quickly fill in. It's just a good way to break the ice, keep you awake at this time of the afternoon. Okay, here we go. Jordan, no. Now I'm wondering what the color scheme here is. Okay, a few more people still typing. Amsterdam. 3 people still typing. All right. I think you can carry on after this as well. So let's move on to the next question. This is more relevant for the session now. We broke the ice. Now this is for me to get a bit of information on who's here today. And okay, great. So this is really helpful because I want to understand what your knowledge is of the solution that I'm talking about. And okay, so the majority here I can see you are not a Secure Access customer, but you're aware and interested. Okay, well, if I would like to think you're interested because that's why you're here. So, all right, so I think we've got, how many? We've got 35 answers. That's a good number. So thank you for that, and that helps me as we go through the slides together. So, all right, so as we saw, a lot of you sort of have heard of Secure Access, familiar with it, are not necessarily a customer, which is good because the next few minutes I'll start by explaining what Secure Access is. So this is a very high-level picture of what the solution is and what it does, but we could sum it up in a few simple sentences. So first of all, it's hardly going to work, the pointer. It's a cloud-based broker that connects users and devices, which is what's on the left, securely to different destinations, which is what we see on the right. Now, those destinations could be the internet. You can see web there on the top. And then they could also be internal or private applications that are relevant only for your organization, or maybe if you're a partner for your customer's organization. And those private apps could be in public or private cloud. They could be on your data center, on your network. And we'll do all the stitching. We'll add the policy and the security along the way. And that's the black box in the middle. This is all cloud-based. So basically, we say we'll connect securely anything from anywhere to anything that is anywhere. Okay? Simple. Sort of. Now, if we sort of jump a little bit deeper in and look at that area in the middle, we have a few objectives as well. So first of all, we want to have a great end user experience. At the end of the day, we're all working in different locations today, not necessarily go to an office every day. Those days are finished. We could be hybrid workers in an office, working from home, traveling remotely. So what we want to ensure is that you as an end user have a great experience. If you're connecting somewhere, you don't need to start thinking, do I need to be on the VPN? Which VPN is it? But hold on, I'm on this network, so maybe it's a different VPN. So all of those decisions we take away from the end user, and we actually say we have two expectations from end users. Log in or get your laptop up and open and running and get to work. That's it. Secondly, simpler for or easier for IT. We've built this in a modern dashboard for an admin where everything is done in one place through simple and easy licensing and all-inclusive. So we don't start slapping on all sorts of additional licenses for different functionality. Okay? And then, as I said, it's a single dashboard. So a nice example here is, who's heard of something called digital experience monitoring? DEM, okay, a few nods here. So some vendors might charge you extra for DEM. You might need to run it in a separate dashboard. This is all inclusive in the subscription, and it all runs in the same dashboard. I'll touch on that later. And we're using our own Cisco's Thousand Eyes for this capability. And then at the end of the day, this is a security solution. So we want to keep it secure and safe. And I'll touch on the different layers of security and the different engines and the different types of protection that we're providing. Another question, who's heard of SASE? We can see this here right in the middle. SASE, a buzzword that, yep, okay. So a buzzword today, SASE is bringing together of networking and security, or more specifically, you can see there at the bottom, the networking side is SD-WAN, and the security side is SSC. So we say connect it, secure it, bring it together, that's SASE. What we're going to focus on today, though, is the right-hand side, SSE. So when we think of SSE, a secure security service edge, this is an offering or a product area that maybe 3 or 4 years ago we started to hear about. And some of those analysts out there, when we started hearing about SSE, it was decided by the analysts that these are the core services that should be in every SSE offering. These are like the basics, table stakes. It has to have all of these. So what are we looking at here? We're seeing firewall as a service, which is basically a way of providing in the cloud firewall services. So inline firewall, we're talking about IPS. We're talking about your layer 3, layer 4, layer 7 firewall services, okay? Secure web gateway, that's a way of inspecting and controlling the web traffic. Now, web is a rich protocol. There's a lot we can do at the SWG. We can also add DLP capabilities, data loss prevention. We can control file types. We can look at the content. So it's much deeper than just domains, which you're limited. So there's a lot we can do at SWG. And then also an important part here is zero trust. So this is where we start thinking about connecting users to those internal apps. So a lot of the customers that we talk to, and this might resonate with you as well, are thinking that VPN might be a thing of the past. As we move out to some of those SaaS applications, software as a service running in the internet, we don't necessarily need to connect back to the corporate network via VPN in order to then break out again. If you've got branches, they might get direct internet access. Today it's relatively cheap. So we're seeing more and more, less of the need to connect via those backhaul connections to, from the branches to the main data centers, and also from remote users having to VPN back in order to break out again. So with that, we're seeing the move to zero trust. That comes with challenges. It's not always easy, but we see it as a journey, and we see that we can help you with that journey as well, and I'll touch on that going forward. So those are the basic core capabilities of an SSE. With Cisco Secure Access, we provide a whole lot more than that. So I'm going to touch on some of these as we go through. And again, some of these might be familiar to you, others maybe not, but don't worry, I'll explain most of it. So VPN as a service, this is what I was previously saying, moving away from traditional VPN, and instead of connecting to a VPN head end on your network, we will allow you to connect to VPN concentrators in our cloud. Okay, removing the VPN burden from you. If you're already a Cisco AnyConnect VPN customer, you can use that same client and connect to our cloud service VPN instead, VPN as a service. Digital experience monitoring, I touched on that, but I'm going to talk more about that. DNS security. So that's, DNS is in our DNA. We have Umbrella, which provides the DNS security services, which is part of this offering as well. Remote browser isolation. This is the ability to have like an air gap in the cloud where we have virtual browsers that are recreating that web content, and that gets sent back down to the end user. So that can remove threats. The nice thing about our remote browser isolation is, once again, it does not require any additional licensing. It's fully integrated into the product. Data loss prevention, DLP, I'm going to touch quite a lot on that. Advanced malware protection, of course. Who's heard of Cisco Talos? Probably some of you here. So all of our security, we have the advantage of having Cisco Talos. So that means that we have security not only in the cloud, but we own the network, we own the endpoint. We can see, Cisco gets visibility into all of those locations and all of that traffic with millions of interactions, or billions even, every day, giving visibility and threat intel. So all of this is tied together through Talos. Sandboxing will do for unknown files. And then I'm going to touch also on AI. No presentation will be complete without talking about AI. But I'm going to show you what we are actually doing, not just words, okay? All right, so that's sort of the overview. Let's talk about some of these innovations and touch on some of those areas that I've just been talking about. So first of all, let's talk about the policy here. Who here is familiar with Cisco Umbrella? That's what I thought, quite a lot of hands. So you're probably also aware of the fact that in Umbrella, we had 3 different access policies or security policies, one at the DNS layer, one at the web layer, and then firewall. Now, as an admin, you needed to decide where to configure. So just as an example, if you decided, let's say you don't want to see TikTok in your organization, you needed to start thinking, do I do it at the DNS layer, at the web layer, firewall, maybe all 3? Is it a category? Is it URLs, et cetera, et cetera? So we've simplified that, and there is one access policy that covers all of that. So you just say, I don't want to see TikTok in my organization. We'll take care of the stitching behind the scenes. So we call this an intent-based policy. As an admin, you say what your intent is, and we'll make it happen. The other thing to note about this single policy is it's not only for internet access, but it's also for private access. So you can actually see, my pointer isn't very good, but you can see private access and internet access all in the same policy. Okay, so with that in mind, we said this is an intent-based policy. We've simplified that even more. We've added the Cisco AI assistant. Okay, I mentioned we're going to talk about AI, so here we go. We have an AI-based assistant that does many different things. One of them is helps you with policy. So remembering that this is an intent-based policy, I can use natural language to type into that assistant and tell it what I want to do. Allow Johnny to access Facebook, but not Tom. allow Jonny to access the Jira internal resource, but not Bill. Okay? So you can write to that policy, that assistant, and it will add the rules into the policy for you. Before you enable them, you can just have a look and make sure it's all looking good. Now, as I type to it, it can interact with me. For example, as I said, allow Jonny to access, let's say Facebook, or let's say the AWS internal resource. It will reply back to me and say, well, hold on, I can see more than one user with the name Jonny, which one? I can see more than one internal resource with AWS, which one? So it's going to have that interaction with you. Now, what we're going to do next is take that a couple of steps further. First of all, as I just said, I asked the policy, the assistant, to write a rule into the policy for me. But what if we've already got a rule that's doing something very similar? Instead of just adding a rule and clogging up my policy, that assistant next is going to come back and say, well, hold on a moment. We've got a rule that does exactly that. Let's add the user Jonny into that rule. Okay? And then, how about we take it a step further after that? We don't even need to wait for the admin to ask the assistant to add a rule. It's going to constantly monitor my rules and optimize them for me. So if I've got duplicated rules, it will come back and tell me. If I've got shadowed rules or maybe conflicting rules, it will come back and tell me. So we can keep the policy optimized the whole time. Mr. Admin, this rule hasn't been matched in 4 months. Do you want to keep it? Let's see what it does. No, I don't need this anymore. Let's remove it. So things like that. Okay? Now, there's some other areas that the assistant helps with as well, and I'll come back to some of those later. Actually, let's not come back to them later. Let's talk about it right now. So one of them is a troubleshooting capability as well. So if I'm seeing that a certain user is having trouble accessing a certain resource, I can type in natural language. You can see at the top, it's a bit small. Why Lee Meadows cannot access the Jira application. And then it will go and investigate for me. And what it's going to do is use synthetic capabilities sending out to the endpoint agent and simulate that traffic for me, that request. And it will tell me all the way along. You can see from the device, is it enrolled? Does it have access policy, et cetera, all the way from the endpoint to the resource, and tell me along the way what could be a potential issue or what is an issue as well. And I can also fine-tune that along the way. I can say what the device type is and things like that. I can change the resource, the user, et cetera, et cetera. So that all of that is inside the AI assistant. All right, so what I've spoken about up to now is AI for security, meaning we're using AI to help a security admin do their job. Let's flip it and now talk about AI for security. Sorry, security for AI, so I've confused myself. So thinking today of generative AI, it's a great tool. It can help us with our work. You know, we can prompt, we can ask, again, using natural language in the prompt, help me with some code that does ABC, or other things. We can send some code outbound. Could you check this for errors? But hold on, that's a security risk, right? That's exposing my intellectual property into a generative AI engine. Okay, we all know what happens when you share anything into a Gen AI engine. It's gone forever. It's out there. That engine is going to use it for training. So I could end up with my intellectual property ending up in someone else's hands. So while generative AI is really helpful, we might not want to block it outright. And we can add these guardrails. We can add protection. And through our DLP, data loss prevention, we can look out for sensitive data like source code, scripting, other sensitive PII, personal identifiable information, and block it. Credit cards, all of the thousands of templates from all the different countries, as you would expect, it's all there. And then what will happen if an end user says, okay, can you check this code for errors? We'll block that. But if they ask for something generic, can you give me a recipe for stroopwafel? They'll get that recipe, okay? Another thing, and we can today identify 1,200 generative AI applications. So that's a lot. Now, when we think of data loss prevention in general, we think of also known as data leakage. We think of data leakage going outside of the organization, and we want to stop that. In the case of generative AI, our DLP engines work the other way as well. So it's inbound as well. Why? Just like I don't want my intellectual property ending up in someone else's hands, I don't want somebody else's intellectual property coming into my organization, because that's a liability. Okay, so DLP for generative AI is inbound and outbound. Still thinking about DLP, remember we do all of our enforcement in the cloud. Some customers might have an enterprise DLP on their network. So we've added integration with secure ICAP. ICAP is a way that DLP platforms or systems can talk to each other. And what we're doing here is we are sharing, every time we have a DLP event, we're sharing those logs back through secure ICAP into the enterprise DLP on-prem to complete the picture. So all of the DLP events can be in one place. Simple thing, but something we've been asked for a lot. All right, still thinking about CASB. So usage of applications. This is third-party apps control. And what we're doing here is taking a look and seeing how our corporate credentials are being used for third-party apps. So what's the use case here? I download a game onto my phone, let's say, and I want to start playing, and it asks me to log in or create an account. So I could create an account with a username and password, or I could see log in via Facebook, log in via Google, log in via Microsoft. I've got Microsoft credentials, let's log in. And the next thing we know, we've used our corporate credentials, and then it's asking, do you want to share? Yes, yes, agree, 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 agree. Next thing you know, you've shared your corporate credentials with some third-party app that has access to your messages, your email, your contacts, your calendar. So as an admin, I can now review all of the third-party apps where my corporate credentials have been shared. And this works for, it says here Microsoft 365, but literally as of today, we added Google as well. I didn't get it in the slide. But Microsoft and Google, we can see where users have shared their corporate credentials, and we can revoke that. So this is using OpenAuth to share credentials. An admin can go and revoke that. Okay, that's the use case here. I touched on this before. This is Experience Insights. This is our digital experience monitoring. And we're using Thousand Eyes, our own technology, to do this. So on all of the endpoints, we put a client, and that client does lots of different things. It provides the VPN as a service that I spoke about. It does posture using Duo, our own capability as well. It does the Zero Trust, and also Thousand Eyes. So as an admin, I can take a look and see end-to-end experience, what it looks like right now for all of my endpoints out there on the network. I can run, again, synthesized tests and simulate traffic going end-to-end to a SaaS application, to a private app. I can see what that looks like. I can see if maybe there's issues on the endpoint. It could be going down to CPU memory. I can even see if there are CPU and memory issues, which is the process on the endpoint that is causing them. Okay, so this can be proactive. And as I said, we can run synthesized testing as well. Let's see, I think I've covered everything here. Yeah, and this is all included in the licensing, like I said before. So touching on that, and I've sort of mentioned this already, these are the synthesized tests that you can run, and you can simulate that. This is something literally, I think, in the last couple of weeks we added this. Not just the proactive monitoring, but being more proactive and launching those tests to see what the experience looks like. The only thing I'll add is you do need to have a 1,000 eyes essentials or advantage license to do this. But what we've added here is the capability to run those tests in the Secure Access dashboard. So digital experience monitoring or experience insights is included. It's part of the licensing. It's just for these additional end-to-end tests, you need to have that 1,000 eyes license as well. So I've touched on this as well, but we've taken it a step further. Going back to the AI assistant, I said I'll come back. The AI assistant has another capability. It can run all sorts of other statistics and help you with troubleshooting as well. So I can say, ask a general question, how many users do I have right now running out of the Frankfurt office? And it will give me a rundown. How many end users in the Netherlands have access problems right now? Which are the SaaS applications right now with the highest latency? And as I ask questions, it will give me some more suggestions for additional follow-up questions I can ask as well. So this is good for troubleshooting and getting general statistics on what's going on in my organization right now. And by the way, another capability that we'll be adding into the AI assistant is reporting. So I could then use, again, natural language. Please run me a report telling me the top 5 users over the last 30 days that consumed the most bandwidth. Okay, so things like that. I can run custom reports and ask the assistant to do that for me. It also has capabilities today for procedures and processes. So how do I configure an IPsec tunnel from a Cisco Firepower to a Secure Access? These are the prerequisites. Here are the steps, 1 to 10, and here's a link to the documentation. So there's a lot we're doing today in that AI assistant. We have built-in zero trust capabilities into mobile devices. The way we do zero trust is a little bit different. We're using more modern protocols. Quick is the transport layer. And actually, from Apple iOS 17, this is built in to the operating system thanks to Apple's Enterprise Relay. So the Enterprise Relay was launched about 1.5 years ago, and that was the follow-up from Apple's Private Relay. Now, Enterprise Relay was developed by Cisco and Apple together, and this is how we have added zero trust into the operating system from those mobile devices. In the meantime, we've also added that into Android, generic Android, and also through Samsung, we have a similar collaboration with Samsung as well. SD-WAN is another integration we've done. So with Cisco's own Catalyst, I mentioned before, if you've got secure internet access coming out from your branches, you can enable that to go from those SD-WAN devices through automated tunnels to our cloud, to Cisco Secure Access. So if you've got 100 branches, you would not need to manually configure 100 tunnels. You can do that through templates. You can also see the policy for the SD-WAN admin can see the secure access policy. You can also get visibility through layer 7 health checks of the components that are running on secure access as well. So that's a nice integration there. Last couple of things, I'm keeping an eye on the time here. Secure group tagging, so if you have Cisco ICE, you can integrate there. And I won't call out the whole flow here, but the bottom line here is if you've got your SGTs, you can then make that integration between ICE and secure access, and then you'll see your SGTs and you'll be able to use them in the secure access policy. So not only your user groups and users and AD information, but also SGTs as well. Here's the flow. You make that connection in the dashboard, you integrate the two platforms, then you will get to see your SGTs, and then later you can see them and use them in your policy. All right, just before we end, do any of you have a presence in China? Okay, a couple of hands here. So we've added, we're running, this is in private preview right now. We built a data center in China for secure access. Now, in order to comply with the Chinese regulations, this needs to be a separate entity, managed and run and sold by a Chinese entity. So Digital China Cloud, DCC, is our partner where we are operating this with. So this is licensed separately, but the use case here is for your users that are maybe traveling to China or based in China. They will be able to break out securely to internet and private resources in China. Okay, this should be live by the summer, but if you're interested in trying it in the private preview, we're already signing customers up. All right, so that's pretty much all of the different areas of innovation. There's probably others, but there's just a limit to how much I can go through in half an hour. I could talk all week if they would let me, but they gave me half an hour. But I think just the message here to summarize is that we know that we're not the first vendor to build an SSE offering. And guess what? We're not the second either. But we've been busy over the last 3+ years talking to our customers who have implemented a first-generation SSE, understanding their pain points, and hoping to do this better. We also have the unfair advantage of being Cisco and being able to integrate with our own technologies, which I hope I've been able to demonstrate today. So as a final thought, you might have heard the expression, the early bird gets the worm. We say the second mouse gets the cheese. So any follow-up questions, I'll hang around for a few minutes, but otherwise, I'd like to thank you for your time. Another last comment also, we have a security research group. If you want to help and provide feedback, you could just snap the QR code there and sign up and work with that team to research. And I said we've been talking with customers for the last 3-4 years. We're continuing to do that. Thank you so much.
Okay. Can you hear me, everybody? 1, 2, 3, testing. Yes. All the way to the back. Can you hear me? Loud and clear? Awesome. Thank you. So this might be the last session of the day and perhaps of the event for a couple of you. If that's the case, well, I'm very honored to be the guy delivering that session. And so far, I hope that you're enjoying the event. I don't know if who's enjoying their first Cisco Live ever. Who's a first timer here? Oh, that's most of you. That's great to know. Well, I hope that you can be here with us the next year. You've seen so far what kind of a party it's here, right? For me, I love this event. For me, it's personally like Christmas, so to say. And well, I hope that you enjoyed the session. We'll get started in just a minute, less than a minute. And yeah, I hope that you have great plans for tonight's party and the after party. Why not? All right. Just give 1 more minute. Okay. I believe that we can get started. All right, brilliant. So, well, first and foremost, thank you for being part of this session. My name is Alfonso, and I'm a software consulting engineer from the CX Lisbon Center. And today, I'm very happy to be sharing with you this Cisco U session about a very interesting open source testing framework that I hope that is very useful for all your present and future projects. So at the end of this session, I hope that you're able to take some tips and tricks for this, from this tool, and that you get to know your new favorite robot, right? So in the agenda, I want to start by sharing some ideas of why automated testing really matters. As much daunting as it can be for us as developers, it's really a critical part of all our projects. Also, we'll see the one-on-one of this open source framework, robot framework. I'm sharing with you a couple of demos regarding the most common use cases, like things that will really help you get started with the usage of this framework. And also some demos for seeing it in action on a DevOps pipeline. For those who are familiar with DevOps, you won't let me lie, testing is a critical part for a go, no-go when it comes to CI. And well, last but not least, some best practices and Q&A, right? In this session, we're going to dig deep. Well, not that deep. It's going to be like an introductory session to the robot framework per se, some practical examples, some cool demos. We won't get into detail regarding test-driven software methodologies or other software testing frameworks. But if we can have a conversation later after this session, if you join the Webex Teams chat, I will be more than happy to send you all the information that I've got so that you can get deep into detail with these technologies, right? So getting started, automated testing matters. It can be daunting, yes, it can be cumbersome, but it really, really matters. And we should take it into consideration from the very inception of the strategy of our software development life cycles, right? And I want to share with you these very millennial memes. They're funny for me as a millennial. But it's figure, you won't let me lie in this situation, right? We are developing software. We are at the end of our sprint. We are barely making it there to the end line, right? We have our project managers chasing after us like, hey, what have you done so far? Which are the improvements? What are you doing? What are you doing? And then we always leave, more than often we leave at the end of the sprint, the tests. Of all the features, of all the new components of my use cases, me personally, I've left them all the way down till the end of my sprint. And then I'm kind of desperate when I have to deliver these stories, right? And we kind of get this temptation, as we see in the meme over there. Maybe I don't fix my code to pass the tests. Maybe I need to fix the tests so they pass with my code. I don't know if somebody has felt tempted to do that. Personally, I feel like that more than often. And the thing is that the pure nature of testing is something very variable, right? It changes a lot. There's many different tests out there that can ensure that all our software-defined products are passing or not, that they have the quality that we are expecting, and that they do all the features that we added in this last sprint, right? Could be UI, UX tests, unit tests, functionality tests, smoke tests, end-to-end. There's many, many different tests out there. The thing about automating the testing in our software-defined products is that we can have lots of reusability in there. We can bring modular tests and just adapt them so that they can fulfill, so that they can really verify the new features that I am adding to, this code that I'm working on, right? At the end of the day, tests are nothing more than code, or at least there should be. So we should be able to version them along with our repository, right? Where we have all the code that we're working with. And also, our tests can be the key for a go, no-go in more complex systems. I don't know if, for example, here you can raise your hand if you actively use a DevOps approach when it comes to your software delivery. Or if you are aware of what DevOps is, or a CI/CD pipeline. If you work with that, perfect. A CI/CD pipeline that takes whole control of our delivery should be locked, it should be conditioned to having a comprehensive, bulletproof test suite with all the checks, with all the tests passing with flying colors, right? That's our ultimate goal when we are using this approach on our software delivery lifecycle. Now, in a nutshell, when it comes to defining our tests and actually running them, we have mostly 3 different stages in this process. The first one is setting up our suite, which is creating what we call a staging environment. That is, hey, my software product is out there in the wild, in production, running on a Linux system using this Python version, this Java version, these libraries. I don't know, I have a NetBox container, something like that. So I should be able to replicate that in my staging environment so that later on, I can go into the second phase, which is actually running these tests. My test suites, right? Like TC stands for test cases, which is like my individual tests, which make up a suite. And that way we ensure that if it works here, where I am testing, it will work out there in the wild, where I have it deployed and available for the masses, for the hands of our customers, right? And then finally, the suite teardown, which is pretty much wiping out all these different environments that we created for doing the two latter stages, right? For example, if we are using containers, and I spun up some containers in there, I have some Docker networks, I installed some libraries, whatever, I need to be able to wipe that out for good so that we can start over with another test run, right? Now, maybe you have used in the past Python unit tests, perhaps, like that library, and you read that code, and I don't know, somebody from another team sent to me, and maybe this guy is not in the company anymore, and I have this bunch of tests, and I'm working on this new feature, and I have no idea of what these tests do. Until I run them, I have no clue of the go or no go, if the green or the red. I mean, what it's supposed to mean, right? And then I have to do like some reverse engineering. I have to crack my head around these tests so I can finally make them work. Maybe these tests were, like garbage tests. Maybe they're not relevant anymore. Maybe they were just left there as they were, and maybe I don't even need them. And I'm wasting valuable time of my sprint on cracking my head around these tests that I don't know what they're for, right? It may be worthless in the end. So it all comes around the simplicity of writing an elegant, comprehensive, and scalable test suite. And that's where the robot framework comes into play. As a fun fact, well, not as a fun fact, as a fact per se, this is an open source project. It was created in Finland, and Cisco, along other companies, are actively investing on it, on its adoption, on its socialization, and its development, and so on. The core features about this open source framework are that it is very human readable, it is human friendly, so I can just skim my tests very, very briefly, and I have an idea of what this test is about. I can also add some different features, I can change it at will, and it barely feels like programming. It feels more like telling a story. It feels more like human language. We'll get into those details later on. And also it has some very interesting built-in features, such as HTML reporting. Like we get out of the box for every execution of my tests, I get a really, really nice, comprehensive HTML report. We'll see that in a minute. And then finally, it has a lot of support. It has many different libraries already developed. And if there's something that you need to do that is not covered by the current libraries, you can create your own. Because these libraries, they are created on bare Python. So you can make that happen. It's super easy. And well, you'll see how easy it is to use it in a minute, right? This is the basic structure of a test written on Robot Framework. What you can see here first, it doesn't really look like programming. It looks like, everyday words. It's very, very human readable. It's very friendly to read. Let's go one by one, top to bottom, through these different structures. On the top part there, we have this header called settings. That's where we define, for example, some documentation strings, like who's the author, version, whatever of this test, what's the name of this test, what does it do, all those different things. Then we have the libraries. The built-in libraries, or libraries that I created myself, I can invoke them there. I need to say there that I am importing them. Then we move forward, and I want you to have a look at those two lines there in black. To a suite setup and suite teardown. It is here where I specify what I want to happen whenever I trigger my test and whenever my test is done. So these are things that will happen every time, at the beginning and in the end. Regardless of the test passing or not, they will always happen at the beginning and the end. That's why they're called suite setup and suite teardown. The names of this, like my setup and my teardown, those are custom instructions. I'm telling to my test, hey, I want you to do this. I want you to do that for the setup and the teardown. And we define that in the bottom of the file where we have the keywords. These are, you can imagine them as functions, as like Python functions or whatever language functions, right? We define what they're going to do by using the keywords header over there, and then we give the name. That's the name that we're referencing on top, and then we say, what are we going to do? I will show you later in an example how does this look like, right? And then in the middle of the file, we have the variables. I can declare variables as in any other given language. I can declare them there. And then finally, the definition of my test cases. I have their test case number 1, and in the order in which I put them on a list, they will be executed, top to bottom, always. And you can see there that we have a couple of built-in libraries for date time, operating system, SSH, Telnet. We can also query directly our Cisco devices with these tests, and many, many, many more things, right? There's the page for your reference. And now, without further ado, let's hop into some interesting use cases. I put together these based on personal experiences and also things that I've seen with other customers who are actively using the robot framework. And there's 3 things that people use these like mostly for. It's API testing, database testing, and also custom scripts, whatever programming language, that doesn't matter. Thing is, I'm going to start with the first one, which is our API testing. And for example, I don't know if here somebody uses some Cisco platforms that have open APIs, right? I don't know, DNAC, NSO, and pretty much all the Cisco software suites have their own REST API, right? You won't let me lie. And more than often, we want to test the replies of these platforms. Like, hey, I'm sending you this request, this GET, this POST, this PUT, whatever. And I'm expecting a result. I'm expecting a valid payload. And that's pretty much what I'm going to be testing right now. OK? So in this first case, I have a mock-up API server. This is just for example purposes. It's going to be container-based. I'm going to run right now a fast API container. And I'm going to have these 2 URIs. Post, where the URI of devices, where I can create a new device. Again, this is mock-up, right? Like, this is just a simulation. But with this post, I'm going to create a new device. And then with this get, I will be passing the ID of the device. I will be able to get that information. OK? This is my test. And this is how I will make it happen using robot. First of all, I'm going to be using these libraries. This is where I define my libraries, my imports. We have this library, which already comes built in for any API request, any REST API request. Then I have here some metadata, like author, version, purpose, all that stuff. Now, let's go with my suite setup and my suite tear down. Again, this is all mock-up, but at the end of the day, that's what I want to do with my testing, right? Be able to maybe spin up a container or something like that, set it up, so it's ready to use. So now here I have my mock API server set up. This is my keyword. I'm going to scroll all the way down here. And here I have the definition of that keyword. What is this keyword going to do? You can see here I'm going to set up my mock API server using Docker Compose. Perfect. You can see here the syntax. I will always have these keywords. For example, this one, run process. I will have this indentation. And then I can specify which are the parameters that I'm going to be passing to this keyword, right? Run process allows me to use my shell of my runner system, in this case, my Cisco computer, to do things. What do I want to do here? I want to execute Docker Compose command. I have here a Docker Compose file, very, very small. And here I have the definitions of my different services, right? This is just for the testing right now. I'm going to be spinning up my Docker Compose file where I have my mock API server, right? You can see here that I have the definition of my variables, and it is here from where I'm getting all this information, OK? Then here, when I execute my test, this is going to happen. I am going to be creating this container. And then when my test is done, I'm going to be stopping it and then I will be deleting it, right? Like this is like a normal practice when we do this sort of approach. We create things, then we execute the tests, and then we delete the things that we created. That's like the normal usage of this platform, right? Moving on. Here I have on my variables the data that I'm going to be using in this test. A device ID, device name, and a device IP. Now here, I have my two test cases. I want to create a network device, and I want to delete that, retrieve that network device. Let's go with the first one. Using the library here that I imported, I will create an HTTP session to this URL, which is the one of my mockup server. I will create a JSON with these different variables, the ID, the name, and the IP address. It's going to look like this. And then I will log it because I want to see it. And then I will do a post request to my dummy mockup server on this endpoint here, devices. And then I want to see that the status code that I get back, it's at 200. 200 is good. That means, OK, thumbs up, everything is fine. And then later on, I want to execute this test, retrieve that network device. I want to use the exact same URL. I'm going to use a different endpoint here. And here I want to pass the device ID that I just used. And then I'm going to get the status code of the response. And I want to check the name. I want to check the device IP. If it matches what I have here in the variables, that's good, right? You can see here that the go, no go comes up to comparing strings, comparing numbers, comparing whatever. Here I'm comparing that if what I get from my response is a 200. Here I compare with this should be equal or should be equals as numbers. If these payloads are actually valid, if this is what I expect from my test, right? So without further ado, let's run it. It's as easy as using the keyword robot and then the name of my .robot file. That's it. Nothing more, nothing less. And you can see here that all the tests are passing. 2 tests were here, 2 passed, 0 failed. Now it generated a series of reports. I want to share with you just the HTML. You can see here that this is my API test. Everything is in green. Green is good. It was set up, then it was turned down after the testing. And here you can see it all went well. I sent this payload here. And then my post was completely successful. It all went fine. I got a 200. And then this one here, 200 is what I'm expecting. It all passed. We're all good. Then when I got the file, when I got the device on the other URL, I passed these parameters. I passed the ID here. And then I got this body, the device that I was expecting. And then here, I'm comparing all the other strings. It's all good. You can see here that out of the box, I got this nice HTML report. It's as easy and powerful as that. Now, moving on, we have this second example of databases. This one, I want to share with you that we can use other custom libraries for very specific purposes. In this case, it's going to be a database. I am using a driver for Postgres, which is supported by this library. And it's a very, very easy thing to do. You can see here that, well, first of all, my setup and teardown are the exact same thing. I'm going to be creating a small container with a Postgres database, and I will be loading it with dummy data. You can see here that I'm loading it with these devices. This is one device in Lisbon, one device in Amsterdam, and one device in Mexico City. And then my first test, I'm going to connect to that database. You can see here that I'm passing all these variables that I have here. My credentials, my database name, the driver, all that stuff, I'm passing it here. And I will create this new record in my database. It's an IOSXR in the beautiful, charming town of Guanajuato in Mexico. We're going to pass it here. And I want to make sure that it goes there with, passes with flying colors. And then my other test, I want to get a device. I want to get all the devices in Amsterdam. And I want to check that the records match what I am expecting here. The ID is 2, the city is Amsterdam, the device is an iOS XR, and it is status inactive. So let's give it a go. I have here my command. I will run it. We can see here that we are creating the container. We did the tests. We deleted the container. And again, all tests are passing. Let me show you here. And you can see that everything is in green. Green is good. Here, my insert query went perfectly fine. And I want to show you here something interesting. Sometimes our libraries, they have some rendering features. You can see here that this specific library for databases is actually showing me a really nice table in there, colors and all. It's very, very nice, right? And well, again, all the information is what I was expecting, so all tests are passing nice and fine. Now, finally, our last test of the day, it's maybe have a custom Python script. This Python script does some crazy things, like many, many interesting things, like devices inventory, connectivity, health checks, I don't know, whatsoever. And the way I use this Python script is by passing some inline arguments, right? Like, for example, here, I'm passing the device name, the location, the IP address. We can also test this using Robot Framework. Let's say that maybe this script, if it gives me the status success, that means that everything went well, right? That my inputs are valid, whatever, right? So I'm going to structure my test using the run process, passing with this variable the usage of the script, which would end up being something like this. And then I will expect a bash return of 0, which means that it went well, that Python didn't crash or something weird. And then I'm going to save that into a file and see if it contains the string success, right? Again, it is a dummy script, but well, it's just for the demo purposes. We can see here we have one test, one passed. You can see that here we don't have a suite setup or teardown because we really don't need it. This is just a standalone Python script, nice and fine. So if I see it here, I refresh the result. Yeah, it all looks good. I got the output gave me a 0, which is bash for OK. And then here I have the string success. It all looks well, right? Now, I want to jump, just to wrap it up, I want to jump into a very quick example for DevOps. And for this one, actually, I'm going to be putting on the hat of dev lead, right? Developer lead. That person in the team that everybody hates, that person that chases after people for checking their PRs, if their code is working or not. I'm going to be that person right now. And here what we are looking at is a repository of some small services of NSO, or Network Services Orchestrator. By the way, does somebody know what NSO is, or has anybody worked with NSO, perhaps? Awesome. We can maybe discuss later, because you might want to have a look at this repository. Don't tell anybody, but I'm stealing this one from another presentation that I delivered on Tuesday. But it serves for the purpose, right? Here I have two different merge requests. And you can see here that one of them is healthy, the other one is not. I have put here a pipeline. And this pipeline, we are actually running robot tests. And on this one, you can see that all the different stages are passing. Like, I can build this code. I can test this code with robot. It's going super fine. You can see here in the logs, like the tests are passing. This is healthy code. And my pipeline can make decisions based on this health, right? Like, for example, if I am on my main branch, this can turn into a release. This can be put into production because the tests are passing. What happens when they don't pass? What happens when I need to chase after my engineer? You can see this one here, that the tests are not passing. But we can start troubleshooting because it's very simple, because robot is telling us already what's wrong. I can see here in the logs that the test for this service, for creating some line BTGs, whatever, none of the tests are passing there. What's going on? Well, A common practice is to bundle these test reports, the HTMLs, in what we call an artifact. I can download that artifact from my repository here. Whoop, let me click again. There we go. I can open this artifact. I can have a look at the tests. And well, yeah, surprise, surprise. Something red here. Red is not good. What went wrong here, right? This is the request that I sent to my service, like, hey, can you please create a new line BTG? And then my service, my network services orchestrator, told me, well, no, I can't. And I won't. Why? Well, I'm telling you this. The template that you're using is wrong. I just cannot do it. So, well, at least now I know where can I start troubleshooting this. And this is thanks to the robot reporting, comprehensive robot reporting that I'm doing as part of my CI process on my development lifecycle, right? And we're almost on top of the hour. So, well, this is what went here. I missed to explain this one, but this is what you just saw in the repository. A top-to-bottom process of CI where the key part is testing using my robot framework. And now, last but not least, having said all of this, I want to share with you some best practices that I would love if you could implement them in your own projects. You want to incorporate your robot test suites as part of your user story process. Like, my user story won't be complete unless, as part of this commits, as part of this delivery, I have my robot files. And these files need to mean something, right? They need to be meaningful, and they need to cover all the details of my user story, all those features. And then I need to keep those tests as little, as atomic as possible, so whenever something goes wrong, I can immediately pinpoint what's happening here, and I can start troubleshooting in no time. And then finally, and I love this one, be merciless. All tests must pass, even if it's a formatting thing, even if it's just a break line. All tests must pass, because we never know when that break line is there for a reason. And here I am leaving some references, very interesting links. Please, you can follow these QR codes, so you can have a look at the repository that I just shared with you. It's a public repo for everybody to see. And that would be it from my end. We only have 1 minute left. So maybe just a couple of questions if you would like to. Microphone is all yours now. No? Oh, yes? Please allow me to come here. Yeah. Mm-hmm. 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 Right, that's a very good. Mm. Mm-hmm. 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 That order. Uh-huh. Mm-hmm. Okay, that's a very good question. Thank you. I'm going to go back here to the stage. The question was about whenever on our testing environment we have different elements. In this case, for example, different containers. Maybe I have dependencies in between these containers, and what's going to happen in the order in which I execute, for example, my queries or all that stuff. If that's sorted out by robot, or if we have to do that ourselves. We have to do that ourselves. Robot will only care about the execution of the tests and the suite setup and the suite tear down. The order in which we execute these tests, the order in which we query these different elements, we have to define it. And that's how we need to define these tests and write them top to bottom in the sequential order in which we want to execute them. But then, just to complement the question, if we want to have multiple containers in our testing environment, I strongly recommend you to use Docker Compose. Because we can define all these different containers on a single file, and we can create them or destroy them on using the special keywords that I defined for the suite setup and suite teardown. Maybe we just need, out of 5 containers, I need 3 on this test. So I will just, with Docker Compose, create service 1, 2, and 3. Yes, exactly. You tag your services, and then you create the suite setup keyword on robot, and you use your Docker Compose just for 1, 2, and 3 service, right? For service A, B, or C. Did I respond to your question? Perfect. So we're already on top of the hour. I appreciate your assistance. Please remember to give me a review on the app. This will help me. Your honest feedback will help me to do my job better every time. And for what it's worth, enjoy the rest of Cisco Live Amsterdam, and see you at the party later on. Thank you.